Hello everyone. This time I'll take up integration by parts, one of the most important methods of integration. NCERT exercise 7.6 I'm going to solve along with the concepts of integration by parts. It's also called as the product rule for integrals. Okay, we shall see what is integration by parts formula, and whenever the u substitution and the trigonometric substitution is not possible, normally we apply this method. Whenever there is product of two functions, also we apply this, and it's very useful to integrate logarithmic functions and inverse trigonometry function. If you want to integrate log x, integral of log x can be got by integration by parts. Integrals of inverse trigonometry functions, sin inverse of x, cos inverse of x, tan inverse of x, cot inverse of x, secant inverse of x, and cosec inverse of x. All these integrals can be obtained by integration by parts. It's also called as product rule for integrals. This method is mainly useful to integrate the product of two functions. When u substitution and the trigonometry substitution is not possible, we can adopt this. And also it's useful to integrate the logarithmic and inverse trigonometry functions. And also it's useful to integrate integral of root of a square minus x square, integral of root of x square plus a square, and integral of root of x square minus a square. That is also important. Okay, and also we can integrate integral of secant cube x and cosecant cube x, all those things. And even for GE exam, this method is quite important. Okay, so not only at PU level for various competitive exams and board exams, it's also useful when you go to engineering. So integration and differentiation both are very important chapters. You have to learn if you're joining engineering. All these things very fundamental it is. Okay, we shall see what is integration by parts. Okay, the product of the formula we have. Integral of first into second. This is the most important formula. Please learn it so that this entire exercise becomes easy for you. Integral of first into second is equal to first function keep as it is, integrate the second function, minus integral of integrate the second function, differentiate the first function. Hope it's clear. Learn this formula, and the first and the second function should be chosen in accordance to the order of occurrence of islet. In according to the order of occurrence of islet order, in that order which comes first, no, that becomes the first function. That's what I given islet. I stands for inverse trigonometry function, L is logarithmic function, A is algebraic function, T is trigonometric function, and E is exponential function. Inverse trigonometry function we know: sin inverse, cos inverse, tan inverse, secant inverse, cosec inverse, cot inverse. Inverse trigonometry function. Logarithmic function we know: log x base z, log x base 10, log x base 5, correct? Log x base 2, log x base half. They're all logarithmic function. A is algebraic function: x square, 1 plus x cube. They're algebraic functions. T is trigonometric function. E is exponential function: e power x, a power x, 10 to the power x. Trigonometry function no: sine, cos, tan, cot, secant square, etc. They're all trigonometric functions. So in the order of occurrence of islet, islet, which comes first, that becomes the first function. Which comes next, that becomes the second function. Suppose exponential function is that it becomes the second function always. Inverse trigonometry function is the first function, like that. So in according to the order of occurrence of islet, I should choose the first and second function. And sometimes to integrate log x is only one function, no? I can consider into one. So 1 is taken as second function, 1 is algebraic. Log x is logarithmic function, correct? 1 is treated as algebraic function, x power 0. Anything can be written as a power of x is algebraic, okay? So log x into 1 you can take, and log x is first function, 1 is a second function. Like that we should do, okay? And I prove this formula. Suppose I got integral of x into sin x. I'll give some examples here. How to choose the first and second functions. Suppose I got integral of x into sin x. X is algebraic. Sin x is trigonometric. Which comes first? According to islet. Algebraic is first. Then comes the trigonometric. Correct? Algebraic is first. Then comes trigonometric. So this is first function. This is second function. Suppose I got integral of x square into e power x. X square is algebraic. E power x is exponential. So algebraic is first. Exponential is second. Integral of x into log x, if it is there. X into log x. X is algebraic. Correct? Algebraic first or logarithmic first? Logarithmic is first. Algebraic is second. correct? This is first function, this is second function. Integral of first into second. First function keep as is, integrate the second, minus integral of integrate the second, differentiate the first according to Eilate. Okay, learn this formula now itself to work out the problems we need. Also, I'll give the proof of that. Proof won't be asked normally in the exams, but still to understand, we should prove that. Learn the formula again. I'm telling you, integral of first into second is equal to first function keep as it is, integrate the second, minus integral of integrate the second, differentiate the first. Okay, again I repeat, integral of first into second is equal to first function, right, as it is, integrate the second function, minus integral of integrate the second function, differentiate the first function. First and the second function should be chosen in according to the order of occurrence of Eilate. I is inverse trigonometric function, L is logarithmic function, A is algebraic function, T is trigonometric function, E is exponential function. In this order, which comes first, that becomes the first function. Which comes next, that becomes the second function. Okay, is that clear? So Eilate, learn this properly. So don't think that whichever they give first, that is first function. Not like that. In according to the order of occurrence of Eilate. Okay, priority is there, Eilate. In that order, which comes first, that becomes the first function. Which comes next, that becomes second function. Suppose I got integral of e power x into sin x. E power x into sin x. E power x is exponential function. Sin x is trigonometric function. Which comes first in this order? Trigonometric is first, then comes exponential. So sin x is first function. E power x is second function. Understood? How to choose the first and second function? That's also important here. Integral of log x is the give. Log x is log x into 1 I can take. Log x is logarithmic function. 1 is algebraic function. In this order, which comes first? Log is first, then comes algebraic. So first function is log x, second function is 1. Hope you understand. And sometimes if it is product of like root of, if it is given root of a square minus x square, you can take into 1. Into 1 you can take 1 as second function. Sometimes what happens is, if I give two functions in JEE level questions you may come across, there whichever function is easy to integrate, that you can take it as second function. Sometimes they'll give both trigonometric only. Okay, and integration by parts with substitution will be there. Integration by parts, the product of two functions will be there, and that involves substitution. Integrating second function, that second function which is easy, that should be taken as, which function is easy, that function should be taken as second function, because integrating easier function is advantage. Integrating a difficult function is complicated, correct? So difficult function you have to take it as which function easy to integrate, that should take it as second function. Which function is easy to integrate, that you should take it as second function. Like that. That will come to know. By working out many problems, you'll get the idea. Should be exposed to variety of problems, then only you'll get the idea. So I should prove this now. Okay, before going to the problems. Also I got some important formulas. As I told, integration by parts is useful to integrate logarithmic functions and inverse trigonometric functions. I given the list of formula. It's better to learn these formulas for competitive exams. It's very much useful. I'll tell without seeing. Integral of log x is x log x minus x. You can take x common. Log x minus 1. Log x minus 1 is log x minus log e. So log of x by e. So x into log of x by e plus c. Of course. First one I told. Integral of log x is x log x minus x plus a constant c. Further you can simplify using properties of log. Integral of sin inverse of x into sin inverse x plus root of 1 minus x square plus c. Integral of cos inverse of x into cos inverse x minus root of 1 minus x square plus c. Integral of tan inverse x into tan inverse x minus half log 1 plus x square plus c. Integral of cot inverse x into cot inverse x plus half log 1 plus x square plus c. Integral of secant inverse x into secant inverse x minus log of mod x plus root of x square minus 1 plus c. Integral of cosec inverse x into cosec inverse x plus log of mod x plus root of x square minus 1 plus c. Correct? All these things I told without seeing. So you should learn. Being students, if you're writing competitive exams, better to learn all these things. I'll prove all these things, and also I'll prove integration by parts formula. Integral of first into second. That formula also I'll prove it. Okay, for your knowledge, it's required. Anyway, in the exam, they won't ask that kind of question, but still we should prove it. Okay, learn all the integrals of logarithmic and inverse trigonometric functions. Okay, quite useful for competitive exams. Okay, I shall prove this. I shall prove this formula. Okay, I'll add one page here. To prove this, consider starting from d by dx of uv. Starting from d by dx of uv. How do you differentiate the product of two functions, u and v, functions of x, product of two functions. First function keep as it is, differentiate the second. The second function keep as it is, differentiate the first. First function keep as it is, d by dx of v plus v into d by dx of u. Correct? First function keep as it is, differentiate the second function. Plus second function keep as it is, differentiate the first. This follows by the product rule for differentiation. Product rule for differentiation from there and get. Now what I am going to do is integrate with respect to x on each of this. Integrating with respect to x on all of them, correct? Both the sides, so integrate with respect to x. Integrating with respect to x. Integrating with respect to x on both sides. Both the sides we shall integrate with respect to x. Okay. So what I am going to get? Integral of derivative of uv with respect to x is equal to integral of u into d by dx of v with respect to x plus integral of v into d by dx of u with respect to x. Integrate this with respect to x. Okay. Integral of derivative of the function is function. We know that integration and the differentiation are the reverse process of each other or the inverse process of each other. So we should cancel out. Integration and differentiation are going to cancel out. So what do you get? Integral of derivative of uv is equal to uv. Is equal to uv is equal to, here same thing I am going to write, integral of u into dv by dx, okay, with respect to x plus integral of v into du by dx with respect to x. So from this what we get? Integral of, rearranging the terms, u into dv by dx, integral of u into dv by dx with respect to x. From this I want to write an expression for this. This is equal to uv minus integral of v into du by dx with respect to x is equal to uv is equal to uv minus integral of v into du by dx with respect to x. Okay. Now to integrate, now what I am going to do is I want to get my formula as I have shown you. Integral of, what I am doing is I am deducing a formula for integration of the product of two functions. What I had here, integral of first into second is equal to first function keep as it is, integrate the second, minus integral of, integrate the second, differentiate the first. I want to get this. So what I am going to do now is take u as first function, dv by dx as second function. Okay. Take u equal to first function. In the side we shall write like this. Take u is equal to f of x. Take u is equal to f of x. And take dv by dx equal to g of x. Okay. Take u as f of x. dv by dx as g of x. So that I get integral of the product of two functions. Correct. So u is f of x. V is what? We cross multiply from this. Cross multiplication gives dv is equal to g of x into dx. So v is equal to, v I want to find, v is integral of dv, correct? Integral of 1 with respect to v is v, correct? So integral of dv I wrote. That is integral of, what is dv? dv is g of x into dx. From the above equation I wrote. What is u? F of x. So du by dx is f dash of x from this. Also du by dx. Du by dx is equal to f dash of x. U is f of x. So du by dx is f dash of x. So from this, what we have integral of, what is u? F of x. U is f of x. What is dv by dx g of x from this? G of x is equal to u is f of x. What is v? V is integral of g of x. V is integral of g of x dx minus integral of, what is v? Substitute. V is integral of g of x, correct? Integral of g of x with respect to x. What is du by dx? Du by dx is f dash of x. This much into dx. Now name f of x as first function, g of x as second function. We'll get that formula. Starting from the product rule for differentiation, integrating with respect to x on both sides, we get the answer. Integral of first into second. Integral of first into second is equal to first function keep as it is. Integrate the second function minus integral of. Integrate the second function. Differentiate the first function. This is the formula. Integral of first into second is equal to f of x is first function, g of x second function. F of x first function, integral of second function. G of x is second, g of x is second. F dash of x is f dash of x is d by dx of f of x. D by dx of the first function. Correct? So g of x I wrote it as second function. F of x is first function. F dash of x means d by dx of f of x. D by dx of first function. So that's the formula. Learn it, okay? Very important, neat, very useful to work out the problems from exercise 7.6. And for board exams, 2 marks questions they can ask, or they can ask 3 marks questions. Okay? Even for competitive exams, it's quite important. Integral of first into second. First function keep as it is, integrate the second, minus integral of, integrate the second function, differentiate the first function. Okay? Integration by parts is also called as the product rule for integrals. Also called as the product rule for integrals. So I proved this. Okay? Next, I am going to prove all these things now. Before taking up the exercise, we should prove all these things one by one. Learn it, memorize it. For competitive exams, it's required. I'll be doing the synopsis of indefinite integrals also. Okay, that time I'll tell what to study, how to study, all those things. Even the previous year questions for KCET will be done from 1984 to 2025. All the questions of indefinite integral I'm going to do. I'm going to touch even the NCERT exemplar book. Each and every question I'm going to solve of NCERT exemplar book also, from first to last, including the solved examples and even the exercise problems. Everything will be solved one by one. Miscellaneous exercise of NCERT book also will be covered. KCET previous year questions from 1984 to 2025 be done. JEE main also I'm going to finish off everything from 2019 to 2025. From when NTA started conducting JEE exams from 2019 till 2025. Also we got to do JEE synopsis. And one shot also will be there. One shot integration I'm going to do. One shot differentiation I'm going to do. Each and everything will be covered one by one. MCQs will be done of each and every chapter for board exams. Board exams, MCQs are there, no? Each and every chapter I'm going to cover MCQs. Not only second PU, even first PU also I'm going to touch trigonometry, functions, complex numbers, one by one and start. Sets, relations, functions, and also what we are, linear inequalities, permutations, combinations, binomial theorems, sequential series, straight lines, conic section, limits and derivatives, statistics, probability, three-dimensional geometry, all the chapters one by one. Even second PUC also I'm going to finish off all the chapters. All the 13 chapters, each and every exercise, even the miscellaneous exercise will be covered. Okay, so we'll prove these one by one now. Integral of log x. To prove integral of log x, first one, take the integral as I. Let I is equal to integral of log x. Let I be equal to integral of log x. Log x means log x into 1. Log x means what? Log x into 1 dx. Log x is logarithmic function. One is algebraic function. According to I late, log comes first, then comes algebraic, correct? According to the order of occurrence of I late. I late is there, correct? Log comes first, algebraic is next, correct? One is algebraic, one is x power 0, so it's algebraic function. Log x is logarithmic function. So this is the first function. This is your second function, right? Integrate this by parts. Integral of first into second is first function, write as it is. Integrate the second function minus integral of, integrate the second, differentiate the first. First function, keep as it is. Integrate the second function minus integral of, integrate the second function, differentiate the first function. Okay. First function keep as it is. Integrate the second function minus integral of, integrate the second function, differentiate the first function. So what are you going to get from this? Log x into integral of 1 is x minus integral of 1 x and derivative of log x 1 by x. Correct? First function write as it is. Integrate the second function, integral of 1, that is x, minus integral of, integrate the second function, differentiate the first function. Integral of 1 x, derivative of log x 1 by x. So this is equal to x log x minus here x will cancel, integral of 1 with respect to x. So what we get is x log x minus integral of 1 with respect to x is x plus c. Integral of 1 with respect to x is x. If you want, you can take x common and you can use properties of log and simplify it further. So this is equal to x into log x minus 1 plus c, and I can write this as log x minus 1 could be written as log e, correct? 1 could be written as log e. So this is equal to x into log x minus log e is log of x by e. Log x minus log e is log of x by e plus c. Log a minus log b, log of a by b. Correct? So integral of log x is x log x minus x into log x minus 1. X is taken common. 1 could be written as log e because log e base e is 1. If no base is written, the base is e. Log a minus log b, log of a by b. So x into log of x by e. Answer. Next one, I am going to prove integral of sin inverse of x. Correct? Integral of log x I proved. Next, I am going to take up integral of sin inverse of x, cos inverse of x, tan inverse of x, cot inverse x, sec inverse x, and finally cosec inverse x. Correct? We will take one more page to prove integral of sin inverse of x. Second one. Let I is equal to integral of sin inverse of x. Sin inverse of x. Take this as into 1. Take this as into 1. Sin inverse of x into 1 dx. Sin inverse x is inverse trigonometric function. 1 is algebraic function. To integrate this sin inverse of x according to Euler, inverse trigonometric is first, algebraic is second. Correct? This is first function. This is second function. Integral of first into second formula. First function write as it is. First function write as it is. Integral of 1, that is x. Integrate the second function. I'll write the steps. Integrate the second function minus integral of. Integrate the second function. Differentiate the first function. Write the rule properly, apply the formula properly. First function write as it is. Integrate the second function, integral of 1 minus integral of, integrate the second function, differentiate the first function. Integral of 1 with respect to x is x. So what I am going to get is sin inverse of x into x. Sin inverse of x into x minus integral of 1 is x. Derivative of sin inverse of x, 1 by root of 1 minus x square. To integrate this, we can use the method of substitution. Put t equal to 1 minus x square, or directly we can write it as what? Derivative of root 1 minus x square is minus x by root of 1 minus x square. For competitive exams, you can do it directly. It should not take much time. For board exams, you can take more steps. So what is derivative of root 1 minus x square? Derivative of root 1 minus x square is equal to what? Derivative of root x. Derivative of root x is 1 by 2 root x. Correct? 1 by 2 root of 1 minus x square into derivative of 1 minus x square is minus 2x. Correct? 1 by 2 root of 1 minus x square into derivative of 1 minus x square, that is minus 2x. 2 cancels. So what I am getting is minus x by root of 1 minus x square. Correct? Minus 2x. 2 cancels. What I am getting is minus x by root of 1 minus x square. So if you differentiate root 1 minus x square, I get minus x by root of 1 minus x square. So integral of minus x by root of 1 minus x square will be root 1 minus x square. So this minus I can take inside. Integral of minus x by root of 1 minus x square is root 1 minus x square. So answer is x into sine inverse of x plus root of 1 minus x square plus c. Don't do like this for board exams. Okay. Now I wrote like this. This is for competitive exams. If you forget the formula for integral of sine inverse of x, you can do it like this. You can get the answer in 30 seconds. In less than 20 seconds you can do if you do it quite fast. Okay. Suppose you forget the formula for integral of sine inverse of x, you can do it instantly. You can do it. Okay. And get the answer. But for board exam, if this question is asked, you should do all the steps. How to proceed here is, you should integrate this by method of substitution. You have to put t equal to 1 minus x square. Put t equal to 1 minus x square. Method of substitution you should do and get the answer. So this part I will show if you want. This part, how you do for board exams. Okay. Integral of x by root of 1 minus x square. If it is for board exams. How to do? Put t equal to 1 minus x square. Put t equal to 1 minus x square. dt by dx. Derivative of 1, 0. Derivative of x square 2x. So minus 2x. dt by minus 2 is equal to x into dx. So x into dx is minus dt by 2. X into dx is minus dt by 2. Divided by root of 1 minus x square is t. Minus half keep outside. Integral of 1 by root is 2 root t. Correct? 2 root t plus a constant c. 2 cancels. We get minus root of, what is a t? 1 minus x square. Correct? Of course, the constant c is added. So minus integral of x by root of 1 minus x square is minus root of 1 minus x square. Correct? Integral of dt by 2 root t. Correct? That is 1 by 2 is kept outside. 1 by 2 dt by 2 means 1 by 2 kept outside along with negative sign. Integral of 1 by root is 2 root t. 2 cancels. So we get minus root of 1 minus x square. So integral of x by root of 1 minus x square is minus root of 1 minus x square. Minus of minus will become plus. Okay. Hence we got the formula to integrate sine inverse of x. One more page which will add to integrate cos inverse x. Same way you can do cos inverse x. I'll do in short. Okay. I won't do all the steps. To integrate cos inverse x. Take cos inverse x as cos inverse x into 1. Cos inverse x into 1. Into 1 you take. 1 is your second function. Cos inverse x is first function. First function keep as it is. Integral of 1 is x. Directly I'll write. Integral of 1 x minus integral of 1 is x. Derivative of cos inverse x is minus 1 by root of 1 minus x square. Correct? This will be equal to x into cos inverse x minus of minus will be plus integral of x by root of 1 minus x square. Integral of x by root of 1 minus x square is minus root of 1 minus x square, because derivative of minus root of 1 minus x square is x by root of 1 minus x square. So directly I'll write this as minus root of 1 minus x square. X into cos inverse x minus root of 1 minus x square. It follows from the previous one, correct? I already proved derivative of root 1 minus x square is minus x by root of 1 minus x square. So integral of x by root of 1 minus x square is minus root of 1 minus x square, correct? Hence I got integral of x by root of 1 minus x square is minus root of 1 minus x square plus c. Next I'll do tan inverse x. Take I is equal to integral of tan inverse x. Tan inverse x is tan inverse x into 1 and tan inverse x into 1. Tan inverse is inverse trigonometric. 1 is algebraic. According to Euler, inverse trigonometric is first. Then comes algebraic. one is algebraic. So it is taken as second function according to Eilert. So apply the formula now. First function keep as this. Integrate the second function. Integral of 1 is x minus integral of 1 is x. Derivative of tan inverse x is 1 by 1 plus x square. Correct? First function write as it is. Integrate the second function. Integral of 1 x minus integrate the second function. Differentiate the first function. To integrate x by 1 plus x square, you can use method of substitution. I know the formula. Integral of x by 1 plus x square is half log 1 plus x square. Directly I know because it's very standard. Derivative of log 1 plus x square will be 2x by 1 plus x square. Correct? So you can integrate. If you don't know, you can integrate by method of substitution. Put t equal to 1 plus x square. Put t equal to 1 plus x square. dt by dx. Derivative of 1 0. Derivative of x square is 2x. So from this dt by 2 is equal to x into dx. X into dx is dt by 2. So what you get is x into tan inverse x. X into tan inverse x minus integral of x into dx what? dt by 2. dt by 2 divided by 1 plus x square is t. dt by 2 means 1 by 2. Keep outside. So what you get is x into tan inverse x minus half into integral of dt by t is log of mod t. Correct? dt by 2 means 1 by 2. Keep outside. Integral of dt by t is log of mod t. Log of mod t plus c. That is equal to x into tan inverse x minus half into log of mod. T you substitute back. T is 1 plus x square. Correct? Mod of 1 plus x square. Mod is not required here because 1 plus x square is always positive. 1 plus x square is always positive for any real values of x. So mod of 1 plus x square is simply 1 plus x square because 1 plus x square is positive. So what I am going to get is x into tan inverse x minus half log 1 plus x square. X into tan inverse x minus half log 1 plus x square plus c. Next I will prove integral of cot inverse x. Cot inverse x. Integral of cot inverse x is almost same as integral of tan inverse x. I is equal to integral of cot inverse x. Cot inverse x is, you can take it as cot inverse x into 1. Take cot inverse x as first function. 1 as second function. First function keep as it is. Integrate the second function. Integral of 1 x minus integrate the second function. Differentiate the first function. Derivative of cot inverse x minus 1 by 1 plus x square. And minus of minus will become plus here. So what I am getting is x into cot inverse x. Correct? Minus into minus will become plus x by 1 plus x square. Integral of x by 1 plus x square, just remember it's very standard. Half log 1 plus x square. Remember and write directly. It's very standard. Integral of x by 1 plus x square is half log 1 plus x square. That is very useful in differential equation also to find integrating factor of linear differential equation. So x into cot inverse x into cot inverse x plus half log 1 plus x square. Integral of x by 1 plus x square is half log 1 plus x square plus a constant c. Next I am going to prove for integral of secant inverse x. Take I is equal to integral of secant inverse x into 1 you consider. Secant inverse x you write. Secant inverse x into 1. Into 1 you write. Okay. First function secant inverse x. Second function 1. Secant inverse is inverse trigonometric. 1 is algebraic. Algebraic comes next after inverse trigonometry in the order of Eilert. In the order of Eilert, inverse trigonometric is first. Then comes algebraic. Apply integration by parts formula. First function keep as it is. Integrate the second function. Integral of 1 x minus integral of 1 is x and derivative of secant inverse x is what? 1 by mod x into root of x square minus 1. I'll write x, okay. Assume that x is positive and write even though derivative of secant inverse x is 1 by mod x into root of x square minus 1. I wrote 1 by x into root of x square minus 1. So that assuming x as positive means x is greater than 1. Assume x is greater than 1. Assume x is greater than 1 because secant inverse of x is what? The domain of secant inverse of x is such that x is greater than or equal to 1. correct? X is greater than or equal to 1, or x is less than or equal to minus 1. X equal to 1 I won't take because derivative is not defined, correct? For x equal to 1. For x equal to 1, if we take, derivative is not defined of secant inverse of x. 1 minus 1, 0. Denominator becomes 0 is not defined, correct? So I'll take x strictly greater than 1. Don't take x less than minus 1 because I remove mod here, correct? X cancels. What do you get? X into secant inverse x minus integral of 1 by root of x square minus 1. Integral of 1 by root of x square minus 1 is log of mod x plus root of x square minus 1. Because we have this formula, integral of 1 by root of x square minus a square. Integral of 1 by root of x square minus a square is equal to what? Log of mod x plus root of x square minus a square, correct? Plus c. This is the formula. Integral of 1 by root of x square minus a square. So integral of 1 by root of x square minus 1. In place of a you put 1. Log of mod x plus root of x square minus 1. So what we get is x into secant inverse x minus integral of 1 by root of x square minus 1 is log of mod x plus root of x square minus 1 plus a constant c. Finally, I am going to prove integral of cosec inverse x. Okay? Integral of cosec inverse x. Let I is equal to integral of cosec inverse x. Cosec inverse x, you take it as cosec inverse x into 1. Cosec inverse x into 1. 1 is second function here, correct? 1 is algebraic. Inverse trigonometric comes first, then comes algebraic. Apply integration by parts formula. First function keep as it is. Integrate the second function. Integral of 1 x minus integral of, integrate the second function. Differentiate the first function. Derivative of cosec inverse x minus 1 by, I won't write mod x, I write x. Okay, assume that x is greater than 1 once again. Assume x is greater than 1. X cancels. Minus into minus will be plus. So we get x into cosec inverse x plus integral of 1 by root of x square minus 1. Integral of 1 by root of x square minus 1 is log of mod x plus root of x square minus 1. Log of mod x plus root of x square minus 1 plus a constant c. Correct? All the 7 approved. All the 7 have been proved. Okay? Please learn this. Very important for competitive exams. And for board exams also, questions can be asked. Integral of log x is there in the exercise only. I won't do again. Integral of tan inverse x also, I won't do it again. 2 of the questions are there in the exercise. So I won't be doing those 2. Remember, integral of log x and integral of tan inverse of x. Those 2 are there in the exercise problem. So I won't be doing those 2 again. Hope it's clear. Now I'll take the exercise problem 7.6. Integral of x into sin x dx. Take x as first function, sin x as second function. Let I be equal to this. Let I is equal to integral of x into sin x dx. According to Eilert, x is algebraic, correct? T is trigonometric. X is algebraic, sin x is trigonometric. X is algebraic, sin x is trigonometric. So algebraic is first, then comes trigonometric. Apply integration by parts formula. Integral of first into second. First function, write as it is. Integrate the second function. Minus integral of, integrate the second, differentiate the first. Okay? Very easy. First function you write as it is. Integrate the second function. Integrate the second function. Minus integral of, integrate the second function, differentiate the first function. Okay? Integral of, integrate the second function, differentiate the first function. First function keep as it is. Integral of sin x minus cos x. Minus integral of sin x minus cos x. And derivative of x is 1. Minus into minus becomes plus. So what do you get? Minus x cos x. Minus into minus is plus integral of cos x is sin x plus the constant c. Hope it's clear. First function, write as it is. Integrate the second function minus integral of. Integrate the second function. Differentiate the first function. Integral of sin x minus cos x minus integral of sin x minus cos x. Derivative of x with respect to x1. So minus x cos x minus into minus plus integral of cos x is sin x plus the constant c. Finally, add a constant c. Move on to the next one. Integral of x into sin 3x. Take the integral as I. Let I is equal to integral of x into sin 3x. This is first function. This is second function. Algebraic. X is algebraic. Sin 3x is trigonometric. According to I late, log algebraic is first. Then comes trigonometric. Algebraic first. I late. A comes before t. Correct? So first function keep as it is. First function write as it is. Integrate the second function. Integrate the second function. Minus integral of. Integrate the second function. Differentiate the first function. Integrate the second function. Differentiate the first function. Derivative of x. Correct? X into. Integral of sin is minus cos. Integral of sin 3x. Minus cos 3x divided by coefficient of x. Integral of sin is minus cos 3x divided by coefficient of x is 3. After integrating, should divide by coefficient of x. If terms inside the bracket is linear, already given this rule. Integral of f of ax plus b. Integral of f of ax plus b is capital F of ax plus b divided by coefficient of x. After integrating, you should divide by coefficient of x plus a constant c using this, where capital F is the antiderivative of small f. Capital F is what? The antiderivative of small f. Capital F is the antiderivative of small f. First function, write as it is. Integrate the second function. Integral of sin is minus cos 3x divided by coefficient of x3 minus integral of sin 3x minus cos 3x divided by coefficient of x3, and derivative of x is 1. Derivative of x is 1. So what you get? This is minus x cos 3x divided by 3, minus into minus plus, divided by 3 means 1 by 3 keep outside. Okay. Integral of sin is minus cos 3x divided by coefficient of x3, derivative of x with respect to x1, 1 by 3 is kept outside. What is left is integral of cos 3x. Integral of cos 3x is sin 3x divided by 3. So this is equal to minus x cos 3x divided by 3, correct, plus 1 by 3 into integral of cos 3x is sin 3x divided by coefficient of x, that is 3, plus a constant c. Integral of cos is sin 3x divided by 3. If you want, you can multiply this. 3 into 3 is 9 here, correct? So what I'm going to get is minus x cos 3x divided by 3 plus sin 3x divided by 9 plus a constant c. Hope it's clear. Minus into minus plus 1 by 3 is kept outside. Integral of cos 3x sin 3x divided by coefficient of x3. 3 into 3, 9. So we get the answer in this. Hope it's clear. Already asked for Karnataka board exams for 2 marks, I think. This type of question. 2 marks or maybe 3 marks, not sure. Move on to the next one. Integral of log x I already did. Again, I won't repeat this. X log x minus x already done in the previous. That is in the previous slides I have done it. I have proved it as a formula. Correct? Integral of x log x. To integrate this, take the integral as I. Let I is equal to integral of x into log x. X is logarithmic function. X is algebraic function. Log x is logarithmic function. Log comes first according to I late. Correct? According to I late, log is first. Then comes the algebraic. Correct? Log comes before algebraic. So log x is first function. X is second function. Correct? First function, second function. First function keep as it is. First function write as it is. Integrate the second function. Minus integral of. Integrate the second function. Differentiate the first function. Like this. Applying integration by parts formula. First function, write as it is. Integrate the second. Minus integral of. Integrate the second function. Differentiate the first function. So what we get? This is equal to log x into integral of x. Integral of x is x square by 2 minus integral of x is x square by 2 into derivative of log x is 1 by x. So this is equal to x square by 2 into log x. X square by 2 into log x minus 1x will cancel. 1 by 2 keep outside. 1 by 2 keep outside. 1x got cancelled. 1x remains. Correct? X dx. Integral of x is x square by 2. So what I am going to get is x square by 2 into log x minus 1 by 2 into integral of x is x square divided by 2 plus a constant c. So x square by 2 you can take common here. X square by 2 is common. So what remains is log x minus 1 by 2 plus a constant c. X square by 2 is common. Log x minus 1 by 2 plus c. Hope it's understandable. Correct? First function write as it is. Integrate the second. Minus integral of. Integrate the second function. Differentiate the first function. Integral of x is x square by 2. Integral of x square by 2. Derivative of log x with respect to x 1 by x. Of which 1 by 2 kept outside. 1x will cancel. So integral of x x square by 2. X square by 2 is common. X square by 2 common. So what remains? Log x minus 1 by 2 plus c. Move on to the next one. Take this integral as I. Once again, x is algebraic. Log x is log 2x is logarithmic. Log is first, then comes algebraic according to I late. Take the integral as I. I is equal to x into log of 2x. X into log of 2x dx. Log is first function. X is second function. First function, second function. First function, write as it is. Integrate the second minus integral of. Integrate the second, differentiate the first. Applying integration by parts formula. First function keep as it is. Log 2x. First function write as it is. Integrate the second function. Integral of x minus integral of. Integrate the second function. Differentiate the first function. d by dx of log of 2x. First function write as it is. Integrate the second function minus integral of. Integrate the second function. Differentiate the first function. This is equal to what? Log 2x into integral of x is x square by 2 minus integral of x is x square by 2. Derivative of log of 2x is 1 by 2x into derivative of 2x, that is 2. By chain rule it follows. Derivative of log of 2x is 1 by 2x into derivative of 2x, that is 2. Here 2 cancels. 1x will cancel. So what is left is x square by 2 into log 2x. X square by 2 into log 2x minus here 1 by 2 keep outside. X square by x is x. Integral of x is x square by 2. So what we get is x square by 2 into log 2x minus 1 by 2 into integral of x is x square by 2 plus a constant c. You can take x square by 2 common here. X square by 2 is common. So what remains is log of 2x minus 1 by 2 plus a constant c. Hope it's clear. Add a constant c for every indefinite integral. Correct? First function write as it is. Integrate the second. Integral of x square by 2 minus integral of. Integrate the second, differentiate the first. Integral of x square by 2. Derivative of log of 2x 1 by 2x into derivative of 2x 2 cancels. 1x will cancel. 1x remains. Integral of x square by 2. So x square by 2 is common. Log 2x minus half inside the bracket plus a constant c. Move on to the next one. Question number 6. Take this integral as I. Let I is equal to integral of x square into log x dx. X square is algebraic function. Log x is logarithmic function. Correct? Log is first. Then comes algebraic according to Eilert. Log comes before algebraic according to Eilert. So first function write as it is. First function is log x. First function write as it is. Integrate the second function. First function write as it is. Log x. Integrate the second function. Minus integral of. Integrate the second function. Differentiate the first function. Is that clear? First function write as it is. Integrate the second. Minus integral of. Integrate the second function. Differentiate the first function. So this is equal to log x into integral of x square is x cube divided by 3 minus integral of x square is x cube divided by 3. Derivative of log x is 1 by x. Correct? First function write as it is. Integrate the second. Integral of x square x cube by 3 minus integral of x square x cube by 3. Derivative of log x 1 by x, of which 1x will cancel here. So what is left here? X cube divided by 3 into log x minus this 1 by 3 keep outside. 1x will cancel. So what we get is x square dx. 1 by 3 keep outside. X cube by x is x square. So this is equal to x cube divided by 3 into log x minus 1 by 3 into integral of x square is x cube divided by 3 plus a constant c. Correct? 1 by 3 keep outside. X cube by x becomes x square. Integral of x square is x cube by 3. You can take x cube by 3 common here. X cube divided by 3 is common. So what remains is log x minus 1 by 3 plus the constant c. Move on to the next one. Question number 7. X into sin inverse of x. Take this integral as I. Let I is equal to integral of x into sin inverse of x. Sin inverse of x is inverse trigonometric function. X is algebraic function. Correct? According to Eilert. Which comes first? Inverse trigonometric is first. Correct? So this is your first function. This is your second function. First function sin inverse of x. Second function x. We can integrate this by parts, or else I can go by method of substitution and then parts. Both. Any method you can do. I'll do both the methods, okay, for you. So first function keep as it is. Integrate the second function. First function keep as it is. Integrate the second function. Minus integral of. Integrate the second function. Differentiate the first function. Using integration by parts. First function write as it is. Integrate the second. Minus integral of. Integrate the second. Differentiate the first. So what we get? This is equal to sin inverse of x into integral of x is x square by 2 minus integral of x is x square by 2. Derivative of sin inverse of x is 1 by root of 1 minus x square. Okay. First function write as it is. Integrate the second. Integral of x square by 2 minus integral of. Integrate the second function. Differentiate the first function. To integrate this, we can use the method of substitution, trigonometric substitution. Okay, call this as star. I'll substitute back later. Consider integral of x square by 2 into root of 1 minus x square. Consider integral of x square by 2 into root of 1 minus x square. For this, we put x equal to sin theta. put x equal to sine theta. Derivative of sine theta is cos theta. Dx by d theta. Derivative of sine theta with respect to theta is cos theta. So dx will be cos theta d theta. Dx is equal to cos theta d theta. Correct? So this becomes equal to, what is x? Sine theta. So this becomes sine square theta, correct, divided by 2 into root of 1 minus sine square theta. Dx is cos theta d theta, correct. Here 1 minus sine square is cos square, root of cos square is cos theta will cancel that, correct. 1 by 2 into this is cos theta, correct. This is nothing but cos theta, because 1 minus sine square is cos square, root of cos square theta is cos theta, assuming that it is positive. Cos theta cancels. What is left is sine square theta, and sine square theta is, to integrate sine square theta you should use the power reducing formula, 1 minus cos 2 theta divided by 2. Sine square theta is 1 minus cos 2 theta divided by 2. 2 into 2 becomes 4 there, correct. 1 by 4 into integral of 1 minus cos 2 theta, correct. Integrate this, what do you get? 1 by 4 into integral of 1 with respect to theta is theta. Integral of cos 2 theta is sin 2 theta divided by 2, plus a constant c I'll add later finally, because this is my original integral, correct. Here I have to substitute the equation star, I have to substitute, because I consider integral of x square by 2 into root of 1 minus x square and got like this. Theta I have to substitute back finally, correct. So I can simplify this one more step. X is sin theta. If x is sin theta, cos theta will be root of 1 minus x square, that is also there. So 1 by 4 into, this is theta minus sin 2 theta is what formula? 2 sin theta cos theta. 2 sin theta cos theta divided by 2, correct. 2 cancels. So what I am going to get is 1 by 4 into theta minus sin theta cos theta. See, sin theta is x. If sin theta is x, cos theta is what? We know cos theta is root of 1 minus sin square theta, taking the positive square root, because cos square theta is 1 minus sin square theta. So root of 1 minus, what is sin theta? X. So sin square theta is x square, correct. Therefore this becomes, I'll write here this part, that's equal to 1 by 4 into what is theta? Theta is sin inverse of x, because x is sin theta, theta is sin inverse of x, minus what is sin theta? X. What is cos theta? Root of 1 minus x square. This part you can substitute. Therefore my integral I becomes, therefore integral I is equal to what? X square by 2 into sin inverse x, x square by 2 into sin inverse of x minus, correct. This part is done, correct. Separately I consider integral of x square by 2 into root of 1 minus x square. I got here this much. 1 by 4 into minus 1 by 4 into what? We have sin inverse x minus x into root of 1 minus x square, plus a constant c finally. If you want, you can take sin inverse of x common there. Sin inverse of x you can take common and simplify it, or else you take LCM as 1 by denominator 4 LCM, right. So 4 is common denominator, correct. 2 into 2, so I'll get 2x square. 2x square into sin inverse of x minus sin inverse of x, minus into minus plus x into root of 1 minus x square, correct. Therefore I can write this as 1 by 4, denominator is common, so sin inverse of x is common here in the first two terms. 1 by 4 into sin inverse of x common, what remains? 2x square minus 1, correct, plus x into root of 1 minus x square, plus x into root of 1 minus x square, plus a constant c. Is that clear? I took common denominator 4, so 2x square sin inverse, because 2 into 2 gives 4, that 2 into this 2x square sin inverse x minus sin inverse x, because 4 into 1, 1 into that, so minus sin inverse x plus x into root of 1 minus x square. Denominator 4 means 1 by 4. Sin inverse of x common here, correct, between these two terms. 2x square minus 1 plus x into root of 1 minus x square. You can do it by other method also. That is by using substitution. I can put sin inverse of x as t and write everything in terms of t. That also possible. That is another method. Okay, you can try that method also. Tan inverse of x, already I have done it. Okay, if you want, I'll do one more here, integral of x into cos inverse of x, so that we can compare, okay, these two, because this is frequently asked in many competitive exams. Integral of x into sin inverse of x, correct? 1 by 4 is outside, sin inverse of x into 2x square minus 1 plus x into root of 1 minus x square. Remember this as a standard result, because many times questions are asked based on this. Can write like this: x by 4 into root of 1 minus x square plus 1 by 4 into sin inverse of x into 2x square minus 1. Like that also you can remember. X into root of 1 by 4 into x into root of 1 minus x square plus sin inverse of x into 2x square minus 1. I'll do x into cos inverse of x also. Okay. One more question I'll do. This I've done already. Again I won't do. After this we got x into tan inverse of x. Before that I'll add one slide here and do integral of x into cos inverse of x. Integral of x into cos inverse of x. Here I'll do by method of substitution. Okay, put t equal to cos inverse x and do. Put t equal to cos inverse x. I'm doing the other method. Put t equal to cos inverse x. Differentiate this. dt by dx. Derivative of cos inverse x is what? Minus 1 by root of 1 minus x square. Correct? Don't differentiate. I'll convert it to trigonometric function and then differentiate. Convert it to trigonometric function and then differentiate. Don't differentiate like this. T equal to cos inverse x. T equal to cos inverse x. Correct? From this. From this, I can write x is equal to cos t. X is equal to cos t. Now I differentiate with respect to x. Derivative of x with respect to x1. Correct? Or dx equal dx by dt, find out. Dx by dt. Differentiate with respect to t. Derivative cos t is minus sin t. Correct? Or I get minus dx is equal to dx equal to minus sin t dt. Okay? Dx we want. Dx is minus sin t dt. Is equal to x is what? X is cos t. X is cos t. Cos inverse x is t. Cos inverse x is t. Cos inverse of x is t. X is cos t. Dx is minus sin t dt. Writing everything in terms of t. Minus sin t dt. Minus you keep outside. Integral of t into sin t into cos t. Sin t into cos t is sin 2t by 2. Correct? Sin 2t divided by 2, because sin 2t is 2 sin t cos t. Divide by 2 means keep 1 by 2 outside. Minus 1 by 2 outside. Integral of t into sin 2t. Now integrate this by parts. Okay? T is algebraic. Sin 2t is trigonometric. According to Euler, algebraic is first, then comes trigonometric. This is first function. This is second function. Correct? First function keep as it is. Constant keep outside. First function keep as it is. Integral of sin is minus cos. Minus cos 2t divided by 2. Minus integral of. Integrate the second function. Minus cos 2t divided by 2. Derivative of t with respect to 1. First function keep as it is. Integrate the second. Minus integral of. Integrate the second. Differentiate the first. So what we get? This is equal to. Minus half is kept outside. This is minus t into cos 2t divided by 2. Minus into minus plus 1 by 2 keep outside. Integral of cos 2t is sin 2t divided by 2. Integral of cos 2t is sin 2t divided by 2 plus c. So write everything in terms of x. Okay. So cos 2t we can write the formula. This you can multiply minus into minus plus 1 by 4 t into, because we make a substitution t equal to cos inverse of x, we have cos t is equal to x. Cos t is x means cos 2t is 2t square minus 1. Correct? Cos 2t formula 2 cos square t minus 1. Correct? I'll write the formula first. Cos 2t is 2 cos square t minus 1. cos 2t is 2 cos square t minus 1. Minus into minus will be plus. This will be how much? 1 by 2 into 1 by 2 into 1 by 2 is 1 by 8. And sin 2t formula, 2 sin t cos t. 2 sin t cos t. Correct? So the 2 ones are 2 2s are cancels. So this will be 1 by 4 into, what is t? T is cos inverse x. Cos inverse x into 2 into cos t is x. Cos t is x. Correct? 2 ones are 2 fours are. So minus 1 by 4. Sin t is what? If cos t is x, I know sin t is root of 1 minus, sin t will be root of 1 minus cos square t. Correct? This will be root of 1 minus x square. Because sin square plus cos square is 1. Sin square t is 1 minus cos square t. So sin t is root of 1 minus cos square t. So sin t is root of 1 minus x square. 2 to cancel. 2 ones are 2 fours are. Sin t is root of 1 minus x square. And cos t is x. Correct? This into x plus a constant c. Like this we get. So we can take 1 by 4 outside here. So 1 by 4 if you take outside, what I am going to get is cos inverse x into 2x square minus 1 minus x into root of 1 minus x square minus x into root of 1 minus x square minus x into root of 1 minus x square plus a constant c. 1 by 4 is common. Cos inverse x into 2x square minus 1 minus x into root of 1 minus x square. See, earlier we got for integral of x into sin inverse of x. I did another method here. Here I directly use integration by parts and get the answer, and finally keep the answer in terms of x. In this x into cos inverse x, I did by method of substitution first. To begin with, I am using method of substitution and then I am using parts. Both methods we can, any method you can do. Okay. So here answer is 1 by 4 into cos inverse x into 2x square minus 1 minus x into root of 1 minus x square. Their answer was 1 by 4 into sin inverse x into 2x square minus 1 plus x into root of 1 minus x square. Both are comparable. Correct? Here cos inverse x, there is sin inverse x. Here minus, there it is plus. Clear, no? Integral of x into sin inverse of x. We got 1 by 4 into sin inverse x into 2x square minus 1 plus x into root of 1 minus x square. Whereas integral of x into cos inverse x, we are getting 1 by 4 outside. Cos inverse x into 2x square minus 1 minus x into root of 1 minus x square. Both they can easily compare and remember. Outside 1 by 4, here also, there also. Inside the bracket, here it is sin inverse x into 2x square minus 1. There it is cos inverse x into 2x square minus 1. Here plus x into root of 1 minus x square. There it is minus x into root of 1 minus x square. So we can take it as standard result, because here and there it's required. For competitive exams, better to learn. So I'll write here what we got. Integral of x into sin inverse of x is equal to what? 1 by 4 into sin inverse x into 2x square minus 1. Sin inverse x into 2x square minus 1, okay, plus x into root of 1 minus x square plus a constant c. Integral of x into cos inverse x. Integral of x into cos inverse x is equal to 1 by 4 into cos inverse x into 2x square minus 1, 2x square minus 1 minus x into root of 1 minus x square. Okay. Both you can remember easily. Comparable. 1 by 4 outside for both. 2x square minus 1 is common term in both. For sin inverse, sin inverse. For cos inverse, cos inverse. For here plus, for sin inverse plus x into root of 1 minus x square. For cos inverse minus x into root of 1 minus x square. Is that clear? Learn this. Next one I should do integral of x into tan inverse x. Again, you should apply integration by parts and get the answer here. Integral of x into tan inverse x. Take the integral as I. Let I is equal to integral of x into tan inverse x. Take Tan inverse x as first function, x as second function. According to Eilert, inverse trigonometric is first. X is algebraic. According to Eilert, inverse comes first before algebraic. So this is your first function. This is the second function. Integral of first into second. Apply integration by parts formula. First function keep as it is. First function keep as it is. Integrate the second function. Minus integral of. Integrate the second function. Differentiate the first function. Correct, is equal to tan inverse x into integral of x is x square by 2 minus integral of x is x square by 2. Derivative of tan inverse x is 1 by 1 plus x square. Correct. First function keep as it is. Integrate the second function minus integral of integrate the second, differentiate the first. X square by 2 is there. 1 by 2 keep outside. Okay, this is equal to x square by 2 into tan inverse x minus 1 by 2 keep outside. What we have, integral of x square divided by 1 plus x square. Like this we get. For this, what you do is we can express the numerator in terms of denominator, because the numerator x square, denominator is 1 plus x square. So add 1, subtract 1. Add 1, subtract 1 here. So what we get is x square by 2 into tan inverse x. X square by 2 into tan inverse x minus half into integral of add 1, subtract 1, because I want to express the numerator in terms of denominator so that it is reducible to standard form. Integrating any function means always you have to reduce it to the standard form so that it is possible to integrate. Now I will separate the terms. 1 plus x square by 1 plus x square minus 1 by 1 plus x square. So what you get is x square by 2 into tan inverse x minus half into, integrate this, integral of 1 plus x square divided by 1 plus x square minus integral of 1 by 1 plus x square. Correct? Separate the terms. 1 plus x square by 1 plus x square minus 1 by 1 plus x square. Correct? Separating the terms. Numerator is difference of two terms. A minus b by c is a by c minus b by c. So what I get? I is equal to x square by 2 into tan inverse x. X square by 2 into tan inverse x minus half into what we have inside the bracket here. 1 plus x square is going to cancel. Integral of 1 it becomes. Integral of 1 is x. Numerator same as denominator cancels. So integral of 1 is x minus integral of 1 by 1 plus x square. It's very standard. Tan inverse x. Because derivative of tan inverse x is 1 by 1 plus x square. So integral of 1 by 1 plus x square is tan inverse x. So minus tan inverse x plus a constant c. You can take tan inverse x common here. X square by 2 into tan inverse x minus half x minus into minus plus half tan inverse x. Open the bracket here like this, simplify. Minus half x minus into minus plus half tan inverse x. So tan inverse x common, correct? You can take half tan inverse x common. Half tan inverse x is common from the first and the third term between these two. Half tan inverse x common. So what remains is x square plus 1 minus half x plus a constant c. Correct? Half into tan inverse x common, x square plus 1 minus half x plus c. So get like this, simplified form. Integral of x into tan inverse x. X is algebraic. Tan inverse x is inverse trigonometric. According to Eilert, I is first, inverse trigonometric is first, then comes algebraic. First function, second function. First function keep as it is. Integrate the second minus integral of, integrate the second, differentiate the first. Integral of x, x square by 2 minus integral of x, x square by 2. Derivative of tan inverse x, 1 by 1 plus x square. The 1 by 2 keep outside. X square by 1 plus x square. Add 1, subtract 1. Separate the terms. Then integrate. 1 plus x square by 1 plus x square. minus 1 by 1 plus x square. Integral of 1 it becomes integral of 1 is x. Integral of 1 by 1 plus x square is tan inverse x. Okay, this is the answer. Integral of x into tan inverse x. Half into, I took tan inverse x common, half tan inverse x common between the first and the third term, half into tan inverse x out. So x square plus 1 minus half x plus c. Move on to the next one. Integral of sin inverse x the whole square. Take the integral as I. Let I be equal to this. Let I is equal to integral of sin inverse x the whole square. Sin inverse x the whole square. Into 1 you take. Then we shall apply integration by parts for this. Sin inverse x the whole square into 1 dx. 1 is first function. 1 is algebraic. Sin inverse is inverse trigonometric. Correct? 1 is algebraic. So sin inverse is inverse trigonometry. Inverse trigonometry is first function always. 1 is second function. According to Euler, I comes first. Inverse trigonometric first. Then comes algebraic. Correct? So sin inverse of x the whole square is first function. 1 is second function. Apply integration by parts for this. First function keep as it is. Integrate the second function. Minus integral of. Integrate the second function. Differentiate the first function. This is equal to sin inverse takes the whole square. Integral of 1 is x minus integral of 1 is x. Derivative of sin inverse x the whole square is 2 sin inverse of x into derivative of sin inverse x 1 by root of 1 minus x square by using chain rule. Derivative of sin inverse x the whole square is 2 sin inverse x into derivative of sin inverse x 1 by root of 1 minus x square. Correct? First function keep as it is. Integrate the second minus integral of integrate the second, differentiate the first. Derivative of x square is 2x. Likewise differentiate. Derivative of sin inverse x the whole square 2 sin inverse x into derivative of sin inverse x 1 by root of 1 minus x square. Now to integrate this I can use method of substitution. Put t equal to sin inverse x because derivative of sin inverse x is 1 by root of 1 minus x square. To integrate this I'll make a substitution. Put t equal to sin inverse x. Put t is equal to sin inverse of x. Differentiate this. dt by dx. dt by dx is equal to derivative of sin inverse x 1 by root of 1 minus x square. Correct? So from this dt is equal to dx by root of 1 minus x square. dt is dx by root of 1 minus x square. Cross multiply. Derivative of sin inverse of x 1 by root of 1 minus x square. So dt is dx by root of 1 minus x square. dx by root of 1 minus x square is dt. Correct? So this is x into sin inverse x the whole square minus for this part. Okay, I am writing everything in terms of t for that. X is sin t from this because you put t equal to sin inverse of x. I'll get x is equal to sin t. X is sin t. So substitute here. X is sin t. 2 we can keep outside. 2 is kept outside. Sin inverse of x is t. Sin inverse of x is t. And x is sin t. Sin inverse of x is t. X is sin t. From this, x is sin t. And dx by root of 1 minus x square is dt. Now again use integration by parts for this. T is algebraic, sin t is trigonometric. According to Euler, algebraic is first, then comes trigonometric, correct? According to Euler. According to Euler. Algebraic comes first, then comes trigonometric. T is algebraic. Sin t is trigonometric. So this is first function. This is second function. Correct? So this is equal to x into sin inverse x the whole square minus 2 into integrate this by parts. Taking first function as t, second function as sin t. First function write as is. Integral of sin t is minus cos t minus integral of sin t is minus cos t Derivative of t is 1. Derivative of t with respect to t is 1. Now further open this bracket and simplify and finally substitute back for t. So this is equal to x into sin inverse x the whole square minus into minus will be plus 2t cos t. Yeah, minus into minus is minus. Integral of cos t is sin t, correct, plus a constant c, finally substitute back for t. Okay, and sin t is x means cos t will be root of 1 minus x square, because you know cos t is root of 1 minus sin square t. Cos t is what? Root of 1 minus sin square t, because you know sin t is equal to x, the cos t will be root of 1 minus x square, correct. So this becomes I is equal to what? X into sin inverse x the whole square, x into sin inverse x the whole square plus 2 into what is the t? T is sin inverse of x and cos t is root of 1 minus x square, because cos square plus sin square 1. So cos square is 1 minus sin square. Cos t is root of 1 minus sin square t. Sin t is x, so root of 1 minus x square I get. So I am substituting back everything in terms of x. T is what? T is sin inverse of x. T is sin inverse x. And what is my cos t? Root of 1 minus x square. Cos t is root of 1 minus x square minus sin t. Sin t is x plus a constant c. This is the answer. Correct, no? Integrate t into sin t by parts. First function keep as it is. Integral of sin is minus cos minus integral of, integrate the second function. Integral of sin is minus cos. Derivative of t with respect to t is 1. Minus into minus plus 2t cos t. Minus into minus is minus. Integral of cos t is sin t. Minus into minus is minus. Integral of cos is sin. Correct? Then write everything in terms of t. T is sin inverse of x. 2 sin inverse of x. Correct? Cos t is root of 1 minus x square. Minus into minus is minus. Integral of cos is sin. Sin t is x. This is the answer. Is that clear? Move on to the next one. Question number 11. Integral of x into secant square x. Take the integral as I. I is equal to integral of x into secant square x dx. Secant square is trigonometric function. X is algebraic. Algebraic is first, then comes trigonometric, correct? So use by parts formula. First function keep as it is. Integrate the second function. Minus integral of, integrate the second function, differentiate the first function. First function write as it is. Integrate the second function. Integral of secant square is tan minus integral of secant square x is tan x and derivative of x is 1. First function write as it is. Integrate the second minus integral of, integrate the second, differentiate the first. Derivative of x with respect to x1. Integral of secant square is tan. So that is x into tan x minus integral of tan x is log of mod secant x. Log of mod secant x plus c. Derivative of x1. Integral of secant square is tan. Integral of tan is log of mod secant x. Hence we got the answer. First function write as it is. Integrate the second. Integral of secant square is tan minus integral of secant square is tan. Derivative of x with respect to x1. Tan x into 1 tan x. Integral of tan x log of mod secant x. Move on to the next one. To integrate this, we go by method of substitution. Put t equal to cos inverse x, because derivative of cos inverse x is minus 1 by root of 1 minus x square. Let the integral be equal to I equal. Let I is equal to integral of x into cos inverse x divided by root of 1 minus x square. Put t equal to cos inverse x. Put t equal to cos inverse x. Put t equal to cos inverse x. Differentiate dt by dx. Derivative of cos inverse x minus 1 by root of 1 minus x square. Correct? Derivative of cos inverse x is minus 1 by root of 1 minus x square. Cross multiply this. Dx. Dx by root of 1 minus x square I want. So minus dt equal to minus dt is equal to what we get? Dx divided by root of 1 minus x square minus dt. Minus dt is equal to dx by root of 1 minus x square. So what I am getting it? Write everything in terms of t. Because you put t equal to cos inverse x, from this I can write x equal to cos t. X is cos t. X is cos t. Cos inverse x is t. Cos inverse x is t. Dx by root of 1 minus x square is minus dt. Minus keep outside. Integrate this by parts. T is first function. Cos t is second function. Using I late. Minus keep outside. Integral of first into second. First function keep as it is. Integrate the second function. Integrate the second function. Minus integral of. Integrate the second function. Differentiate the first function. Okay. This is equal to minus of t into integral of cos t is sin t minus integral of cos t is sin t, and derivative of t with respect to t is 1 minus of t sin t. Here minus is there. Integral of sin is minus cos plus a constant c. Integral of sin is minus cos, minus of minus plus, and finally you can substitute back for t. So this will be minus t sin t, minus into minus plus, plus into minus is minus. So minus t sin t minus cos t plus c. What is t? Substitute back. T is cos inverse x. So minus cos inverse x. What is sin t? Cos t is x. So sin t is root of 1 minus cos square t, right? Sin t is root of 1 minus cos square t, because sin square plus cos square is 1. Root of 1 minus cos t is x. So becomes root of 1 minus x square. Sin t is root of 1 minus x square minus cos t. What is cos t? X plus a constant c. Minus t is cos inverse x, sin t is root of 1 minus x square. Correct? T is what? T is cos inverse x. T is cos inverse x. Sin t is root of 1 minus x square. Cos t is x. Correct? So this is the answer. If you have a doubt, you can differentiate this so that you get the given question. I'll show if you want. Minus you keep outside. Correct? Minus. You can apply the product rule here, correct? Minus cos inverse x. Take minus cos inverse x as first function. Okay. Derivative of root 1 minus x square. 1 by 2 root of 1 minus x square into minus 2x. That will be minus x by root of 1 minus x square. Again. Minus x by root of 1 minus x square. Derivative of root 1 minus x square directly I wrote. Plus second function. What is my second function? Root of 1 minus x square. Correct? And derivative of minus cos inverse x is 1 by root of 1 minus x square. Correct? Minus of minus plus 1 by root of 1 minus x square. And derivative of x is 1. Derivative of c is 0. This will cancel. This will cancel here. Correct? Plus 1 minus 1 add up to 0. Here minus into minus plus. I'm getting x into cos inverse x by root of 1 minus x square. Here this will cancel. Becomes 1. 1 minus 1 is 0. Hence we get answer as this. When you differentiate this, I am getting x into minus plus x into cos inverse x by root of 1 minus x square. So we get the given question back. Is that clear? Move on to the next one. Integral of x square into e power x. Take the integral as I. X square is algebraic. Let I is equal to integral of x square into e power x dx. X square is first function. e power x is second function. Exponential comes in, that is always the last, that is second function. X square is algebraic. Algebraic comes before exponential. Apply integration by parts formula. First function keep as it is. Integrate the second function. Minus integral of. Integrate the second function. Differentiate the first function. D by dx of x. D by dx of x. That's equal to x square into integral of e power x is e power x. First function keep as it is, integrate the second, minus integral of, integrate the second function, differentiate the first function, derivative x square, sorry. Derivative of x square. X square into integral of e power x, minus integral of e power x is e power x. Derivative of x square is 2x. 2 you keep outside. Then again apply integration by parts for this one. X square into e power x minus 2 keep outside. Integral of x into e power x dx. 2 you keep outside. Integral of x into e power x. Use integration by parts for this. This is first function. This is second function. Correct? X square e power x minus 2 into integral of first into second. First function keep as this. Integral of e power x is e power x minus integral of e power x is e power x. Derivative of x is 1. First into second. First function keep as it is. Directly integrate and write. Integral of e power x is e power x minus integral of integrate e power x. Derivative of x 1. One more step I should write. X square e power x minus 2x e power x minus into minus plus 2 into integral of e power x is e power x plus a constant c. If you want, you can take e power x common. E power x common. What you get? X square minus 2x plus 2 plus a constant c. Take e power x common. What you get? X square minus 2x plus 2 plus a constant c. Correct? What we can do, I can apply a shortcut method for this. Whenever the given integral takes this form, no? X power n into e power ax, this form. Integral of x power n into sine ax, or it takes integral of x power n into cos ax. All these three cases, n is a natural number, a is any real number. Okay, in that case we can apply a shortcut method for this. Okay, that shortcut method is given by this integral of uv. I'll write here for these three types of integrals. Even you can do it for integral of x power n into a power x. For these type of integrals, we can apply the shortcut method. Integral of uv with respect to x. Okay, integral of first into second uv with respect to x, right? Where u and v are functions of x. Okay, that is equal to first function keep as it is. Integrate the second function minus differentiate the first function, integrate the second function. v2 means integral of v1 plus differentiate u dash, we get u double dash, integrate v2, we get v3 minus differentiate u double dash, we get u triple dash. Okay, integrate v3, it becomes v4. Like this it goes on. Continue until it becomes 0. That's a shortcut method useful for CET exams. I'll be doing synopsis part of indefinite integrals separately for KCET and JEE separately I'll do. Okay, for this to integrate this, no, what I'll do is I'll use this. I'll show this integral to get the answer like this. I'll use this method and get the answer. So integral of x square into e power x, x square into e power x dx. This is first function. This is the second function. Correct? First function keep as it is. First function write as it is. Integrate e power x minus alternate plus minus differentiate x square. Look at this now. Don't look there. Look at this. Derivative of x square 2x. Integral of e power x plus next differentiate 2x. Derivative of 2x is 2. Integral of e power x. Next term derivative 2 will be 0 over plus c. Like this. You can take e power x common if you want. E power x if you take common, what do you get? X square minus 2x plus 2 plus a constant c. Like this. What is the answer we got? Same thing, no? E power x into x square minus 2x plus 2 plus c. If you want, I'll give more examples. Already such type of questions are asked in KCET 2008. One question was asked like this. Even in 2019 also, question was asked similar of this type. Okay, use shortcut method and get the answer. Suppose I give bigger ones. Because of x square, no, I should apply integration by parts 2 times. If I give x power 5, then I should apply integration by parts 5 times. That becomes lengthy, time killing, correct? So what I'll do is, I'll add one slide here and show you how to get integral of x power 5 into e power x at one step. X power 5 into e power x. If you are applying integration by parts, I should apply 5 times. It becomes very lengthy, time consuming. So what I am doing is applying the shortcut method. This is first function. This is second function. First function, keep as it is. Integral of e power x, minus, differentiate x power 5, 5x power 4. The integral of e power x, plus, derivative of 5x power 4 is 20x cube, correct? Differentiate 5x cube, differentiate 5x power 5 into 4x cube, 5 into 4x cube, 20x cube. Integral of e power x, minus, derivative of 20x cube is 60x square into integral of e power x plus derivative of 60x square is 120x into integral of e power x minus 120 into integral of e power x. Next term derivative of 120 is 0. So finally it stops. It terminates at this stage. So e power x you can take common. E power x you can take common. What remains? X power 5 minus 5x power 4 plus 20x cube, correct, minus 60x square plus 120x minus 120 close the bracket plus c. Next up it becomes 0, correct? Derivative of 120 is 0. E power x common. Alternate plus minus. First function write as it is. Integrate e power x minus differentiate this, integrate this, plus differentiate this, integrate this, that you write here, minus differentiate this, integrate this, right here. Understood? Differentiate this and write here. Integrate this and write here. Differentiate this here, right here. Integrate e power x. Derivative of 60x square, 120x. Integral of e power x. Derivative 120x, 120. Integral of e power x over. Alternate plus minus. Alternate plus minus. One more I'll give example if you want. Integral of, suppose I give x cube into 5 power x. X cube into 5 power x. Okay. This is first function. This is second function. First function keep as it is. Integrate 5 power x. 5 power x divided by log 5. Correct? 5 power x divided by log 5. Minus derivative of x cube 3x square. Integrate 5 power x by log 5. 1 by log 5 is constant. Integral of 5 power x is 5 power x by log 5 by log 5. Log 5 square becomes 5 power x divided by log 5 becomes log 5 the whole square. Plus derivative of 3x square is 6x. Integral of 5 power x by log 5 square. That will be 5 power x divided by log 5 the whole cube. Correct? By log 5 the whole cube. Minus derivative of 6x, 6. Integral of 5 power x is 5 power x by log 5 cube. So log 5 power 4 it becomes. Minus 6 into here 5 power x divided by log 5 to the power 4. And next step, derivative of 6 will become 0. Finally gone, over, plus c. When it becomes 0 at that stage it stops. Understood? First function, write as it is. Integrate second function. Integral of 5 power x divided by log 5. Minus, differentiate this and write here. Integrate this and write here. Differentiate this, write here. Integrate this and write here. Differentiate this and write here. Integrate this and write here. Understood? Alternate plus minus, plus minus, plus minus. Here you are differentiating d by dx. Correct? Here derivative of 3x plus 6x d by dx. Derivative of 6x 6 d by dx. Here integrating this. Hope I understand all these things. Okay, it's applicable for integrals of which type? X power n e power x, x power n sin x, x power n cos x, and x power n into a power x. These 4 types of integrals you can apply this method. Okay, keeping first function as it is, integrate the second function, alternate plus minus from the previous one, differentiate the first, integrate the second, from the previous one, differentiate the first, integrate the second, go on, continue until it becomes 0. When it becomes 0, stop, over. Is that clear? Next, we move on to this integral of x into log x the whole square. Take this integral as I. Let I is equal to integral of x into log x the whole square. X is algebraic. Log x the whole square is logarithmic. According to Eilert, log is first. Then comes algebraic, correct? According to Eilert. Log comes before algebraic. Log comes before algebraic. Correct? First function keep as it is. First function write as it is. Integrate the second function. First function keep as it is. Integrate the second function. Minus integral of. Integrate the second function. Differentiate the first function. Correct? This is equal to log x the whole square, integral of x square by 2 minus integral of x is x square by 2. Derivative of log x the whole square is differentiate as a differentiate x square, derivative of x square 2x, 2 log x into derivative of log x 1 by x. 2 log x into derivative of log x is 1 by x. Correct? So this is equal to what? X square by 2 into log x the whole square. X square by 2 into log x the whole square minus this 2 cancels. 1 x will cancel. So what is left is integral of x into log x dx. Correct? Integral of x square by 2. Integral of x square by 2. Derivative of log x the whole square. 2 log x into derivative of log x 1 by x. 2 cancels. 1 x got cancelled. So again I should apply integration by parts for this. Correct? This will keep as is. X square by 2 into log x the whole square minus applying integration by parts. Log x is first function according to Eilert. Log comes first, then comes algebraic. This is second function. Integral of first into second. First function write as it is. Integral of x square by 2 minus integrate the second function. Integral of x square by 2. Derivative of log x is 1 by x. So what we get? That's equal to, I'll write here. Therefore, integral I is equal to x square by 2 into log x the whole square minus what we have here 1 by 2 can be kept outside. Open this bracket. X square by 2 into log x square by 2 into log x, correct? Minus into minus is plus. 1x will cancel. 1 by 2 keep outside, correct? Minus into minus is plus. 1 by 2 keep outside. X square by x is x. Integral of x dx. Integral of x is x square by 2, correct? X square by 2 into log x the whole square minus x square by 2 into log x plus 1 by 2 into integral of x is x square by 2 plus a constant c. Can take x square by 2 common finally. X square by 2 is common. So what remains is log x the whole square, correct? Log x the whole square minus log x, correct? X square by 2 is taken out. 1 by 2 plus a constant c. X square by 2 is taken out. Log x the whole square minus log x plus half. Correct? No? Minus, open the bracket. Minus into minus becomes plus. 1x got cancelled. 1 by 2 keep outside. Integral of x is x square by 2. Hope it's clear, no? First function keep as it is. Integrate the second x square by 2 minus second function integrate the second function. Differentiate the first function. Derivative of log x the whole square is 2 log x into derivative of log x 1 x. 2 got cancelled. 1x got cancelled. Integral of x log x. Log x into x square by 2 minus integral of x square by 2. Derivative of log x 1 by x. Simplify it. Move on to the next one. Finally, I took x square by 2 common. So log x whole square minus log x plus half. Move on to the next one. Question number 15. Take the integral as I equal to, that I is equal to integral of x square plus 1 into log x. X square plus 1 is algebraic. Log x is logarithmic. Correct? Take log x as first function. X square plus 1 as second function. According to Eilert. According to Eilert, log is first. Correct? Then comes algebraic. So log x is first function. X square plus 1 is second function. Integral of first into second. First function keep as it is. Integrate the second. Minus integral of integrate the second, differentiate the first. Applying integration by parts formula. First function write as it is. Integrate the second function. Minus integral of integrate the second function, differentiate the first function. First function keep as it is, integrate the second, minus integral of integrate the second, differentiate the first, is equal to log x into integral of x square is x cube divided by 3. Integral of 1 x. Correct? Integral of x square plus 1. Integral of x square with respect to x cube by 3. Plus integral of 1 is x. Minus integral of, again integrate this. Integral of x square is x cube divided by 3. Integral of 1 with respect to x is x. And derivative of log x is 1 by x. Is equal to what we have, log x into x cube by 3 plus x minus here x multiply inside 1 by x multiply inside, what we get, integral of x cube by 3 into 1 by x becomes x square divided by 3 plus x into 1 by x is 1. Correct? X into 1 by x is 1. X cube by 3 into 1 by x will be x square by 3. 1x will cancel when you multiply. Correct? This is equal to log x into x cube divided by 3 plus x minus here x square by 3. I multiplied this, hope you understood. X cube by 3 into 1 by x. When you multiply these two, 1x will cancel, so it becomes x square by 3. X into 1 by x is 1. To integrate this, 1 by 3 keep outside. Integral of x square is x cube divided by 3. Minus into plus is minus. Integral of 1 is x plus a constant c. Correct? Integral of x square by 3. X square by 3 means 1 by 3 into x square. 1 by 3 keep outside. Integral of x square is x cube by 3. Minus into plus minus. Integral of 1 is x. So this is the answer. If you want, you can multiply this. X cube by 9. One more step you can write. Otherwise keep as it is. Doesn't matter. Move on to the next one. Integral of e power x into sin x. E power x is exponential. Sin x is trigonometric. To integrate this, we are using by parts formula. Product rule for integral. Call the integral as I. Let I is equal to integral of e power x into sin x dx. Sin x is trigonometric. E power x is exponential. Correct? Sin x is trigonometric. Trigonometric is first. Exponential is second. According to Eilert. According to Eilert, trigonometric is coming before exponential. Correct? Exponential is the last in the order of Eilert. So exponential becomes the second function. So integrate this by parts. Applying the formula. First function keep as it is. Integrate the second function. Minus integral of integrate the second function, differentiate the first function. Integral of integrate the second function, differentiate the first function. This is equal to sin x into integral of e power x is e power x minus integral of e power x derivative of sin x is cos x dx. Correct? Integral of e power x, derivative of sin cos. Again, I should apply by parts formula because it is product of two functions. Cos x is trigonometric, e power x exponential. first into second, integrate by parts, first function keep as it is, integrate the second, minus integral of, integrate the second, differentiate the first. So what do you get? This is equal to sin x into e power x minus integral of first into second, first function right as it is, integrate the second, minus integral of, integrate the second, differentiate the first. First function keep as it is, cos x, integral of e power x minus integral of, integrate the second function, differentiate the first function, correct, d by dx of cos x. This is equal to sin x into e power x minus bracket cos x into integral of e power x is e power x minus integral of e power x is e power x, derivative of cos x minus sin x. Again I am getting same thing, correct? What was the given question? Same thing I am getting it. So this will not terminate, this will not end, because derivative of sin is cos and derivative of cos is minus sin. It keeps oscillating, sin cos, cos sin, and integral of e power x always e power x only. So this will not end. So that's why I've taken the integral as I. In anyway, earlier questions also I took it as I, the given integral. I'm making it as a habit, okay? But now I'm using this, okay? So what I got, I'll write next line. Sin x into e power x, or I'll write e power x into sin x, e power x into sin x, minus, open the bracket, e power x into cos x, minus into minus into minus is minus, integral of e power x into sin x. I started with integral of e power x into sin x as I. This is also I, correct? This is also I itself. Left hand side throughout I got I here. You can take e power x common. E power x common. What you get is sin x minus cos x minus integral of e power x sin x is I, correct? This is I, correct? Minus I. Integral of e power x into sin x is I from the given equation, or from the equation which we took, correct? This is nothing but I, because integral of e power x into sin x is named as I. Minus I take that, so it becomes plus I. I plus I becomes 2I. Therefore 2I is equal to, minus I is shifted to left hand side, becomes plus I plus I, 2I is equal to e power x into sin x minus cos x. Therefore, I is equal to, finally I am getting e power x divided by 2 into sin x minus cos x. Finally, we can add a constant c. Initially also we can add a constant. That does not matter actually. Adding a constant before or afterwards doesn't matter. Because if you add the constant here itself at this stage, c by 2 will get, correct? C by 2 is a new constant, c dash. Integral of constant does not matter for us. So finally I am adding a constant c. Where you add the constant does not matter, because you are dividing by 2. C by 2 is also constant, c is also constant. Constant is constant only. You can rename the constant, of course. So this is the answer we get. Integral of e power x sin x is e power x by 2 into sin x minus cos x plus a constant c. Hope you understand. Move on to the next one. This is similar to the earlier one. Here it's given integral of e power 2x into sin x. It's an important question for 3 marks. Already asked in the board exams. Take the integral as I. Let I is equal to integral of e power 2x into sin x dx. Exponential is always the second function. Sin x is trigonometric according to Eilert. Trigonometric comes before exponential. So sin x is first function. E power 2x is second function. Integral of first into second. First function keep as it is. Integrate the second. Minus integral of. Integrate the second. Differentiate the first. Correct? So this is equal to sin x into integral of e power 2x. First function keep as it is. Integral of e power 2x. E power 2x by 2. E power 2x divided by 2. Minus integral of. Integrate the second function. E power 2x divided by 2 into derivative of sin x is cos x. Correct? First function keep as is. Integrate the second function. Integral of e power 2x by 2. minus integral of integrate the second function, differentiate the first function. Correct? Integral of e power 2x is e power 2x by 2. Directly I integrate and write. Okay? First function keep as it is. Integrate e power 2x and write. Minus integral of integrate e power 2x, e power 2x by 2. Derivative of sin x is cos x. So what we get is here is equal to e power 2x divided by 2 into sin x minus divide by 2 means 1 by 2 keep outside. For this apply integration by parts. Cos x into e power 2x dx. Cos x is first function. E power 2x is second function. Cos x is trigonometric. E power is exponential. Apply integration by parts once again for this. This is equal to e power 2x divided by 2 into sin x minus 1 by 2 into open a bracket. Apply integration by parts for this. First function keep as it is. Integral of e power 2x, e power 2x divided by 2 minus integral of integrate e power 2x, e power 2x divided by 2 into derivative of cos x minus sin x. First function keep as it is. Integrate the second function minus integral of integrate the second function, differentiate the first function. So what we get is equal to e power 2x divided by 2 into sin x minus 1 by 2 into 1 by 2 is 1 by 4 e power 2x into cos x minus into minus into minus is minus 1 by 2 into 1 by 2 is 1 by 4 integral of e power 2x into sin x dx. Correct? Minus half into half minus 1 by 4 cos x into e power 2x multiply this. Minus into minus is minus 1 by 2 into 1 by 2 is 1 by 4. This is integral of e power 2x sin x, which is same as I. Started with I, I'm getting I again. Whenever there is integral of this type, e power 2x or e exponential into sine or exponential into cos, whenever we get integrals of this type, product of exponential and sine, product of exponential and cos, in that case it won't end. Because when you differentiate sine, it becomes cos. Derivative of cos minus sine, it keeps oscillating. And integral of e power x is e power x only. That's the reason. So this is I. Correct? This entire thing is nothing but I. So this is minus 1 by 4i. Take it to left hand side, it becomes plus 1 by 4i. I can take e power 2x by 2 common here. So left hand side, what is there here? I is equal to e power 2x divided by 2 common. What remains is sin x minus half into cos x. Taking e power 2x common, e power 2x by 2 common, sin x minus half cos x, and this is minus 1 by 4i. Minus 1 by 4 I take that, so it becomes plus 1 by 4i. I plus 1 by 4i. I plus 1 by 4i is equal to e power 2x by 2, e power 2x divided by 2. Here take LCM 2. 2 is common denominator here. Sin x by 1. 2 is common denominator inside the bracket. 2 sin x minus cos x I get. 2 sin x minus cos x. Correct? So that I is common here. I is common. So what remains? 1 plus 1 by 4. This is e power 2x divided by 4. 2 into 2, 4. What remains is 2 sin x minus cos x. And 1 plus 1 by 4 is 5 by 4. Take LCM 4. 4 into 1. 4 plus 1, 5. 5 by 4 I am getting. 5 by 4 I is equal to e power 2x divided by 4 into 2 sin x minus cos x. This 4 is going to cancel here. 4 cancels. Therefore, I is equal to e power 2x divided by 5. Correct? 4 cancels. This 5 is brought to denominator of right hand side into 2 sin x minus cos x. Finally, I add a constant c. So these two questions we worked out. There is a shortcut formula for this. Time saving result I can tell for this. Integral of e power x into sin bx. Also there is a formula for integral of e power x into cos bx. Both the formulas are quite important for competitive exams. Better learn those formulas for CET and JEE exams. Learn those formulas. I'll write the formula here. Integral of e power ax into sin bx. Integral of e power ax into sine bx is equal to e power ax divided by a square plus b square into a sine bx minus b cos bx. A sine bx minus b cos bx plus the constant c. Okay. Here you observe that a is 2 and b is 1. E power ax into sine bx. A is 2, b is 1. Okay. So e power ax, e power 2x by 2 square plus 1 square. 2 square plus 1 square is 5. A is 2, b is 1. Substitute. E power ax, e power 2x by 2 square plus 1 square. That is what we have. E power 2x by 4 plus 1. Put a is equal to 2, b is equal to 1. 2 square plus 1 square is 5. A is 2. So 2 sine 1x minus 1 cos 1x. Put a is equal to 2, b is equal to 1. B is equal to 1, b is equal to 1. So we get this. Correct? Put a is equal to 2. Put a is equal to 2. B is equal to 1. In this formula, we'll get this. Correct? Same way I got formula for integral of e power ax into cos bx. E power ax into cos bx is equal to very similar formula. E power ax divided by a square plus b square into a cos bx plus b sin bx. A cos bx plus b sin bx. Learn this formula, okay? Quite important for CET and many other competitive exams, even for NDA exams, JEE exams. These formulas you may come across, okay? You might come across. That's what given here. Integral of e power x into sin bx with respect to x. E power x by a square plus b square into a sin bx minus b cos bx. Integral of e power x into cos bx is e power x by a square plus b square into a cos bx plus b sin bx. That is what I wrote here, correct? A cos bx plus b sin bx. Here, a sin bx minus b cos bx plus a constant c. Shown here, okay? Move on to the next one. Integral of sin inverse of 2x by 1 plus x square. Take the integral as I. Let I is equal to sin inverse of 2x by 1 plus x square. We know by inverse trigonometric functions, this is standard formula. Sin inverse of 2x by 1 plus x square is 2 tan inverse x. 2 tan inverse x. If you don't know, you can put x equal tan theta and simplify and do. Okay. I can do it by two methods. One is directly I can use sin inverse of 2x by 1 plus x square as 2 tan inverse x and integrate by parts. Otherwise, you can put x equal to tan theta and do. Put x equal to tan theta because 2 tan theta by 1 plus tan square theta is sin 2 theta. Correct? Put x equal to tan theta. Differentiate this. Derivative of tan theta is secant square theta into d theta. This will become what? Sin inverse of terms inside the bracket is 2 tan theta by 1 plus tan square theta. 2 tan theta by 1 plus tan square theta. And dx is secant square theta into d theta. Correct? This is equal to integral of sin inverse of 2 tan theta by 1 plus tan square theta is sin 2 theta. Correct? Secant square theta into d theta. Sin inverse of sin 2 theta is 2 theta. Correct? 2 keep outside. Theta into secant square theta d theta. Theta is like algebraic first function. Secant square theta is trigonometric second function. Isolate. First function keep as it is. Integral of secant square is tan. Minus integral of. Integrate the second function. Integral of secant square is tan. Derivative of theta with respect to theta is 1. Correct? Is equal to 2 into theta tan theta minus integral of tan theta is log of mod secant theta. Log of mod secant theta plus the constant c. Theta substitute back. X is tan theta. So theta is tan inverse of x. Theta is tan inverse of x. So I'll write the answer here. Therefore, I is equal to what we have 2 into tan theta is x. Theta is tan inverse x. Correct? X into tan inverse x, I'll write. Tan theta is x and theta is tan inverse x. Correct? Minus log of secant theta is root of 1 plus tan square theta, right? We know 1 plus tan square theta is secant square theta. 1 plus tan square theta is equal to secant square theta. Or secant theta is equal to mod of secant theta is root of 1 plus tan square theta. Correct? mod of secant theta is root of 1 plus tan square theta. So I'm getting root of 1 plus tan theta is x, root of 1 plus x square, log of root 1 plus x square plus a constant c. So this you can multiply inside. 2x tan inverse x minus 2 into log of root 1 plus x square. Correct? 2 goes to the power. 2 goes to the power using property of log. N log m. What is n log m? Log m power n. Correct? Log m power n. This 2 goes to the power. So what I am getting is 2x into tan inverse x minus 2 goes up. Correct? So log of root 1 plus x square square. Root 1 plus x square square will be 1 plus x square plus a constant c. 2 goes to the power. Root 1 plus x square square is 1 plus x square. You get like this. Otherwise, directly you can use the formula 2 tan inverse x and integrate by parts. Or 2 we keep outside, integral of tan inverse x, formula x into tan inverse x minus half log 1 plus x square. You'll get the same answer. Directly in 2 steps you can write for CET exam. If this question is asked for CET, directly you can answer. This is 2 tan inverse x, 2 you keep outside, integral of tan inverse x into tan inverse x minus half log 1 plus x square. 2 multiply inside, you'll get the same answer. Move on to the next one. Integral of x into e power x. Take the integral as I. I is equal to x into e power x dx. X is algebraic, first function. E power x is second function. According to I late, e is last. Exponential comes the second function. Integral of first into second. First function keep as is. Integrate the second function. Minus integral of. Integrate the second function, differentiate the first function. So what we get? This is equal to x into integral of e power x minus integral of e power x derivative of x is 1. So what you get? This is equal to x into e power x minus integral of e power x is e power x plus c. If you want to get e power x common and write one more step. Move on to the next one. This is similar to the question we did earlier. X cos inverse x by root of 1 minus x square. Similar to that. Here you put t equal to sin inverse of x. Start with method of substitution. Put t equal to sin inverse of x. Put t equal to sin inverse of x. Because you can see root of 1 minus x square in the denominator. No? Derivative of sin inverse of x 1 by root of 1 minus x square. Integration by method of substitution and then parts. Both combination. It's a combo of both. Okay. Differentiate this. dt by dx. dt by dx. Derivative of sin inverse of x 1 by root of 1 minus x square. So from this dt is equal to what? Dx by root of 1 minus x square. Dx by root of 1 minus x square. So given integral I I'll call. Let I be equal to this. I is equal to integral of x into sin inverse of x divided by root of 1 minus x square. Take sin inverse of x as t. So from this x will be equal to sin t. X is equal to sin t. Correct? So from this what we get? Integral of what is x? X is sin t. X is sin t. X is sin t. Sin inverse of x is t. Sin inverse of x is t. Dx by root of 1 minus x square is dt. Integrate this by parts. Taking algebraic. T is algebraic first function. Sin t is trigonometric second function. Apply integration by parts for this. Correct? Put t equal to sin inverse of x. So that x is sin t. Derivative of sin inverse x 1 by root of 1 minus x square. So dx by root of 1 minus x square is dt. Now integration by parts. First function keep as this. Integral of sin is minus cos. Minus integral of sin is minus cos. And derivative of t with respect to t is 1. Correct? First function keep as this. Integrate the second function. Minus integral of. Integrate the second function. Differentiate the first function. Directly I wrote at one stretch. Correct? This is equal to minus t cos t minus of minus plus integral of cos t is sin t plus a constant c. First function keep as it is. T is the first function. T is algebraic. Sin t is trigonometric. First function keep as it is. Integrate the second. Minus integral of. Integrate the second function. Differentiate the first function. Minus of minus becomes plus. What is t you substitute? T is sin inverse of x and x is sin t. If x is sin t, cos t is root of 1 minus sin square t. Taking the positive square root, correct? And sin t is x, no? Sin t is x. So I'll get root of 1 minus x square. So what we get is minus t is what? T is sin inverse of x. Sin inverse of x into cos t. Cos t is root of 1 minus x square plus sin t. Sin t is x plus a constant c. If you want, you can differentiate this. You'll get the given question. Minus sin inverse x into derivative of root 1 minus x square is minus x by root of 1 minus x square. Minus of minus becomes plus x sin inverse x by root of 1 minus x square plus root 1 minus x square into derivative of minus sin inverse x minus 1 by root 1 minus x square. That will become plus minus 1. Minus 1 plus 1 cancels. We get the given question. Hence the answer is correct. If you differentiate this, you should get the given question back. Okay? Which we are getting it. Move on to the next one. Integral of x into cos x. Quite simple one. Take the integral as I. I is equal to integral of x into cos x. X is algebraic. Cos x is trigonometric. According to I late. Cos trigonometric is second, correct? Algebraic comes before trigonometric. X is algebraic. Cos x is trigonometric. Algebraic comes before trigonometric. So x is first function. Cos x is second function. First function keep as it is. Integrate cos x. Integrate the second function. Minus integral of. Integrate the second function. Differentiate the first function. Is equal to x into integral of cos x is sin x minus integral of cos x is sin x and derivative of x is 1 is equal to x into sin x. Integral of sin is minus cos, minus of minus plus cos x plus a constant c. Integral of cos was sin, derivative of x 1, sin x into 1 sin x, integral of sin is minus cos, minus of minus plus cos x. Move on to the next one, integral of e power x cos x. This I'll do directly by using that shortcut formula. Okay, again I won't do all the steps. We know the formula, integral of e power x into cos bx. Anyway, this question is not found in the NCERT book exactly. So directly I'll write the formula and substitute. A is 1, B is 1, correct? A cos bx plus B sin bx. A cos bx plus B sin bx. Substitute A equal to 1, B equal to 1 and get the answer. Correct? E power x into cos bx. So A is equal to 1, B is equal to 1. We want integral of e power x into cos x into dx is equal to e power x divided by 1 square plus 1 square, 1 plus 1 into 1 into cos 1x plus 1 into sin 1x. A is 1, B is 1. Correct? So answer is e power x divided by 2 into cos x plus sin x plus a constant c. Correct? Directly I wrote the shortcut method, a time saving result, and put a equal to 1, b equal to 1. E power 1x by 1 square plus 1 square. A is 1, b is 1. Next one, integral of x into cosecant square x. I is equal to integral of x into cosecant square x into dx. X is algebraic. Cosecant square x is trigonometric. Correct? According to I late. According to I late. X is the algebraic first function. Correct? Algebraic comes before the trigonometric. Second function. First function keep as it is. Integrate the second function. Minus integral of. Integrate the second function and differentiate the first function. This is equal to x into integral of cosecant square x is minus cot x minus integral of cosecant square x is minus cot x. Derivative of x is 1. Correct? This is equal to minus x into cot x minus of minus plus integral of cot x dx. Correct? This is equal to minus x cot x plus integral of cot x is log of mod sin x plus a constant c. Some additional questions I have taken, okay, which is not found in NCERT book as it is. It was x into secant square x that I have done earlier. Now I took x into cosecant square x. First function keep as it is, integrate the second function, minus integral of, integrate the second function, differentiate the first function. Integral of cosecant square x is minus cot x, and derivative of x1, minus of minus plus, integral of cot x is log of mod sin x. Next, integral of tan inverse of 2x by 1 minus x square. This is put x equal tan theta and 2. This is 2 tan inverse x, directly I'll write. This is integral of 2 tan inverse of x. By inverse trigonometry functions, we have this formula. Okay, I won't do the normal method. Directly use the shortcut and write the answer. Integral of tan inverse x is x into tan inverse x minus half log 1 plus x square, correct? Integral of tan inverse x into tan inverse x minus half log 1 plus x square. Half log 1 plus x square plus a constant c. Multiply 2 inside. So we get 2x tan inverse x. Here 2 cancels. 2 into half becomes cancelled. So we get log of 1 plus x square plus a constant c. Next we got integrals of this type. Integral of e power x into f of x plus f dash of x. We know this result. Integral of e power x into f of x plus f dash of x. Integral of e power x into f of x plus f dash of x. Very standard. This is equal to e power x into f of x plus c. Correct? Learn this as a standard formula. Very useful even for MCQ board exams. In 2025 Karnataka PU board exams, the question was asked based on this. 2 marks and 3 marks questions also very often you can find of this stuff. Even for competitive exams, CET, JEE, NDA, this is commonly asked question. Okay? Proof also I can give. We can start from d by dx of e power x. Proof. Consider d by dx of e power x into f of x. D by dx of e power x into f of x. Consider derivative of this. You can apply the product rule for this. First function keep as it is. Derivative of f of x, f dash of x, plus second function keep as it is. Derivative of e power x, that is e power x. Correct? E power x common here. E power x, if you take common, what you get is f of x plus f dash of x. Integrate on both sides with respect to x. Integral of d by dx of e power x into f of x with respect to x is equal to integral of e power x into f of x plus f dash of x with respect to x. Here integration and d by dx are going to cancel out. So what remains is e power x into f of x plus a constant c. That's equal to integral of e power x into f of x plus f dash of x. Hence we get the answer. Integral of e power x into f of x plus f dash of x is e power x into f of x plus c. Move on to the next one. The problems connected to this. Take the integral as I here. Like I is equal to integral of e power x into tan inverse x plus 1 by 1 plus x square. We know that derivative of tan inverse x is 1 by 1 plus x square, right? So this is your f of x and this is f dash of x. F of x is tan inverse of x. F dash of x is 1 by 1 plus x square. Correct? Derivative of tan inverse x is 1 by 1 plus x square. So the given integral takes the form e power x into integral of e power x into f of x plus f dash of x. F of x plus f dash of x. So this becomes equal to e power x into f of x plus c. What is my f of x? Tan inverse x. Derivative of tan inverse x 1 by 1 plus x square. F of x, f dash of x. Integral of e power x into f of x plus f dash of x is e power x into f of x plus c. So e power x into what is my f of x? Tan inverse of x plus a constant c. E power x into tan inverse x plus c. Next one. This is f of x, this is f dash of x. Derivative of sin x cos x. Orally we can answer. Answer is e power x into sin x plus c. Over, right? For MCQ they can ask. Correct? I'll do all the steps in detail. Integral of e power x into sin x plus cos x. Comparing this with e power x into f of x plus f dash of x. Comparing with integral of e power x into f of x plus f dash of x. What is my f of x? Sin x. Correct? Derivative of sin x, cos x. F of x is sin x, f dash of x is cos x. where f of x is equal to sin x and f dash of x is cos x. Derivative of sin x cos x takes the form integral of e power x into f of x plus f dash of x. My f of x is sin x, f dash of x is cos x. So integral of e power x into f of x plus f dash of x is e power x into f of x plus c. Substitute back for f of x finally. F of x is sin x, e power x into sin x plus a constant c. Move on to the next one. Question number 3. Take the integral as I. Sometimes it is not so easy to identify f of x and f dash of x. Correct? This is x into e power x divided by 1 plus x square. 1 plus x the whole square. In the earlier two questions, we could identify what is f of x and f dash of x very easily. Sometimes if trigonometric function is there to make use of trigonometric formula. Here to make some adjustments here. I'll express the numerator in terms of denominator. X is there now in the numerator, add 1, subtract 1, so that I can express the numerator in terms of denominator. Denominator is 1 plus x the whole square. I can write this as, to reduce it to that form. That form is integral of e power x and f of x plus f dash of x. In that form I should get, so that I can write the answer as e power x and f of x plus c. No need to integrate. We are not integrating by any known methods. Using the direct result, e power x and f of x plus f dash of x. So what we can do is x you keep as it is, add 1, subtract 1. Add 1, subtract 1, divided by 1 plus x the whole square. This much into e power x dx. Correct? What I did, e power x is kept outside the bracket. Add 1, subtract 1. Then separate the terms. Divide individually. This is equal to integral of x plus 1 divided by 1 plus x the whole square. Correct? Minus 1 divided by 1 plus x the whole square. Separating the terms. Divide individually into e power x dx. Separate the terms. Divide this by this by this. X plus 1 by 1 plus x the whole square. Minus 1 by 1 plus x the whole square. Numerator is sum of two terms or difference of two terms. So separate this. This by this by this. Here x plus 1 is same as 1 plus x. Now one of them will cancel. So this becomes integral of 1 by 1 plus x. Correct? X plus 1 is same as 1 plus x. 1 plus x will cancel. So what is left here is minus 1 by 1 plus x the whole square into e power x into dx. Here take f of x as 1 by 1 plus x. Derivative of 1 by 1 plus x minus 1 by 1 plus x the whole square. Correct? You know, derivative of 1 by x is minus 1 by x square. Derivative of 1 by 1 plus x will be minus 1 by 1 plus x the whole square. Correct? Take f of x as 1 by 1 plus x. If you differentiate this, I get this. So it takes the form integral of e power x into f of x plus f dash of x. F of x is 1 by 1 plus x. Derivative of 1 by 1 plus x is minus 1 by 1 plus x the whole square. Minus 1 by 1 plus x the whole square. So this is equal to integral of e power x into e power x. This is f of x and this is f dash of x. E power x into f of x plus f dash of x. Answer is e power x into f of x plus c. That's equal to e power x into, what is f of x? 1 by 1 plus x plus a constant c. Can be asked for 2 marks. Write the numerator in terms of denominator. Add 1, subtract 1. Then separate the terms. Divide individually. X plus 1 by 1 plus x the whole square. One of the term will cancel, x plus 1. So get 1 by 1 plus x minus 1 by 1 plus x the whole square. This is f of x, this is f dash of x. E power x into f of x plus f dash of x. E power x into f of x plus c. F of x is here, f dash of x is here. As comparing, getting the answer. Move on to the next one. Here directly we can tell this is f of x, correct? F of x is 1 by x. And f dash of x is minus 1 by x square. Derivative of 1 by x is minus 1 by x square. E power x into f of x plus f dash of x. So answer is e power x into f of x. E power x into f of x plus a constant c. What is f of x? 1 by x. So answer is e power x into 1 by x plus a constant c. Next one, take this integral as I. As I told, if there is trigonometric function, it is simplified using trigonometric formulas most of the time. 1 plus sin x divided by 1 plus cos x. We can't identify easily what is f of x and f dash of x here. What we'll do is you will make use of the formulas here. 1 plus cos x, we use the half angle formula, 2 cos square x by 2. And sin x, we know 2 sin x by 2 cos x by 2. Use those formulas. Sin x is 2 sin x by 2 cos x by 2. Using half angle formulas. 2 sin x by 2 cos x by 2. 1 plus cos x is 2 cos square x by 2. 1 plus cos x is 2 cos square x by 2. Correct? So make use of half angle formulas here and simplify it. E power x into 1 plus sin x is 2 sin x by 2 cos x by 2. 1 plus cos x is 2 cos square x by 2. 2 cos square x by 2. Separate the terms. This is equal to integral of e power x into. Separate the terms. Numerator is sum of two terms. Separate it. What do we get? 1 by 2 cos square x by 2. 1 by 2 cos square x by 2 plus 2 sin x by 2 cos x by 2 divided by 2 cos square x by 2. Separating the terms. 2 cos square x by 2. Correct? Separate the terms. A plus b by c. A by c plus b by c. Correct? Separating the terms. This becomes integral of e power x into 1 by 2, right first. 1 by cos square is secant square. So this is half into secant square x by 2. Correct? Plus here 2 cancels. 1 cos will cancel. Cos square means cos into cos. So 1 cos has been cancelled. Sin by cos is tan. Tan x by 2. Derivative of tan x by 2 is secant square x by 2 into derivative of x by 2 is 1 by 2. Correct? Derivative of tan is secant square. Derivative of tan x by 2 is secant square x by 2 into derivative of x by 2 is 1 by 2. So take f of x equal to tan x by 2. F of x is tan x by 2. Show the steps in the side. F dash of x is equal to derivative of tan x by 2 is what? Secant square x by 2 into derivative of x by 2 is 1 by 2. Correct? So this is f of x. This is f of x. And this is f dash of x. So this is equal to e power x into f of x. F of x is tan x by 2 plus c. E power x into f of x. Derivative of tan is secant square. Derivative of tan x by 2 is secant square x by 2 into derivative of x by 2 is 1 by 2. Move on to the next one. Same type of question is there, similar type of question. Integral of, take the integral as I. That I is equal to integral of e power x into 2 plus sine 2x divided by 1 plus cos 2x. Again make use of trigonometric formulas. Sine 2x we know, 2 sin x cos x. 1 plus cos x is 2 cos square x, right? Make use of this double angle formula and the power reducing formula. Double angle formula only. 2 plus sine 2x is 2 sin x cos x. 1 plus cos 2x is 2 cos square x. 1 plus cos 2x is 2 cos square x. Sin 2x is 2 sin x cos x. 1 plus cos 2x is 2 cos square x. Numerator is sum of two terms. Separate the terms. Divide individually. Integral of e power x into, what do you get? 2 divided by 2 cos square x plus 2 sin x cos x divided by 2 cos square x. Separating the terms. Divide individually. So what we get? This is equal to integral of e power x into, here 2 cancels. 1 by cos square x, that is secant square x. Correct? Secant square x. Here 2 cancels. 1 cos will cancel. Sin by cos is tan. This is f of x. Correct? This is f dash of x. F dash of x. It takes the form integral of e power x into f of x plus f dash of x, which is e power x into f of x. Answer is e power x into tan x plus c. Because we know integral of e power x into f of x plus f dash of x is e power x into f of x plus c. One plus cos 2x is 2 cos square x. Sin 2x is 2 sin x cos x. Separate the terms. 2 by 2 cos square x. 2 sin x cos x by 2 cos square x. 1 2 will cancel. Cos cancel. Sin by cos tan. 2 2 cancels. 1 by cos square is secant square. Derivative of tan is secant square. F of x, f dash of x. Here we got c. E power x into tan x by 2. Correct? Here we are getting e power x into tan x. Here it was 1 plus cos 2x. Then it was numerator 2 plus sin 2x. Correct? Similar types of questions. They can give in terms of 1 minus cos x by 1 minus sin x also. This question can be modified. They can give like this also. E power x into 1 minus sin x divided by 1 minus cos x. This kind of question also they can ask. Okay, which is not found in the NCERT book, but already asked in the CET exam, this type of question. Sin x, you can write half angle formula, 2 sin x by 2 cos x by 2. 1 minus cos x is 2 sin square x by 2. We'll get in terms of cot and cosecant square. Derivative cot is minus cosecant square. In terms of cot and cosec, you'll get. Same way they can ask for this type also. E power x into 2 minus sin 2x by 1 minus cos 2x. All those things you can practice. Integral of e power x into 2 minus sin 2x divided by 1 minus cos 2x. They can ask these kind of questions, slightly modified, correct? Instead of plus, we got minus in both numerator and denominator. Sin 2x we can use 2 sin x cos x, and 1 minus cos 2x is 2 sin square x. Like that, the questions can be modified and asked. Okay? And also we can generalize and write the shortcut also for this. They can ask even instead of sin 2x, they can ask sin 4x. Correct? If they ask a question like this, integral of e power x into here it was 1 plus sin x, no? 1 plus sin x. Here if I give 2 plus or 4 plus sin 4x, 4 plus sin 4x divided by 1 plus cos 4x. I can give like this. In that case, what? In that case, the answer will be e power x into 4 plus sin 4x. I can write it as 2 sin 2x cos 2x. 2 sin 2x cos 2x. And 1 plus cos 4x is 2 cos square 2x. Correct? 1 plus cos 4x, 2 cos square 2x. This will be integral of e power x into, separate the terms, 4 by 2 is 2 and 1 by cos square is secant square. Secant square 2x plus here 2 cancels, 1 cos will cancel, sin by cos tan 2x, and derivative of tan 2x is secant square 2x into 2. This is f of x, correct, and this is your f dash of x. So integral of e power x into f of x plus f dash of x, e power x into f of x. Answer for this will be e power x into tan 2x. E power x into tan 2x plus c over. Correct? So we can generalize this. What is the generalized form is integral of e power x into a plus sin ax. A plus sin ax divided by 1 plus cos ax. Correct? In this form. In this form is given. Answer is e power x into tan ax over e power x into tan ax. Tan ax by 2 will get, no? Tan ax by 2. If it is 4x, it becomes 2x. If it is 2x, it becomes x. E power x into tan ax by 2. Correct? I can prove it if you want. I'll give the proof also for this. I'll give a proof for this. E power x into a plus sin x by 1 plus cos x. Integral of e power x into a plus sin ax divided by 1 plus cos ax. Correct? Answer will be e power x into tan ax by 2. E power x into tan of ax by 2 plus a constant c. Correct? Proof. Integral of e power x into a plus sin ax will be 2 sin ax by 2 cos ax by 2. Correct? 2 sin ax by 2 into cos ax by 2. And denominator 1 plus cos x is 2 cos square ax by 2. Then separate the terms. Correct? Divide individually. This becomes integral of e power x into, separate the terms. This becomes a by 2 into 1 by cos square is secant square. Secant square ax by 2. Correct? Plus here 2 cancels. 1 cos will cancel. Sin by cos is tan ax by 2. Derivative of tan ax by 2 is secant square ax by 2 into derivative of ax by 2 is a by 2. Correct? This is your f of x. This is your f of x. And this is your f dash of x. If you differentiate tan ax by 2, you get secant square ax by 2 into derivative of ax by 2 is a by 2. This is the f dash of x. So integral of e power x into f of x plus f dash of x. E power x into tan ax by 2 plus c. Same way I can write the result like this. Integral of e power x into a minus sin ax divided by 1 minus cos ax. 1 minus cos x. This will be in terms of cot, no? Minus will get minus e power x into cot x by 2. Correct? 1 minus cos will be sin. Correct? Minus cot will get. Correct? No? If you simplify this, e power x into a minus sin ax is 2 sin ax by 2 cos ax by 2. Correct? 1 minus cos ax is 2 sin square ax by 2. This will be 2 sin square ax by 2. Then separate the terms. What will get? This will be e power x into a by 2 into 1 by sin square is cosecant square. Correct? Cosecant square ax by 2. 2 cancels. 1 sin cancels. Cos by sin is cot. And derivative of minus cot is plus cosecant square. Correct? So we'll get the answer like this. This is your f of x and this is your f dash of x. Hence answer is e power x into minus cot x by 2 plus c. Learn this formulas. Quite useful. Suppose I give integral of e power x into, directly I can write the answer. 8 plus sin 8x divided by 1 plus cos 8x. What is the answer? Directly I can write. Answer is e power x into tan 4x plus c. That's a quite useful result. Directly I wrote the answer. They can ask for CET. Already asked this type of question earlier in many exams, various competitive exams. So along with NCERT, you can study even for competitive exams. That will be useful. Okay. Move on to the next one. Here you can multiply the secant x inside. I is equal to integral of e power x into secant x multiply inside and right. Secant x into 1 secant x plus secant x into tan x. Secant x tan x. This is your f of x. This is f of x. This is f dash of x. Correct? Integral of e power x into f of x plus f dash of x. F of x is secant x. Derivative of secant x is secant x tan x. So answer is e power x into f of x. F of x is secant x plus c. Correct? Derivative of secant x tan x. So answer is e power x into secant x plus c. Open the bracket, multiply inside. Secant x into 1 secant x. Secant x into tan x tan x. Similar type of question can be asked in terms of cosecant cot. They can ask like this, integral of e power x into cosec x into 1 minus cot x. Same type of question. Correct? This you can write it as integral of e power x into cosec x into 1 is cosec x. Correct? Minus cosec x into cot x. And in this case, this is your f of x. Derivative of cosec x is minus cosec x cot x. This is f of x and this is f dash of x. So answer is e power x into f of x. E power x into cosec x plus c. Correct? Derivative of cosec x is minus cosec x cot x. Move on to the next one. Integral of x minus 3 e power x by x minus 1 the whole cube. Take the integral as I. Let I is equal to integral of x minus 3 into e power x divided by x minus 1 the whole cube. I should write the numerator in terms of denominator. Write x minus 3 as x minus 1 minus 2 so that I can separate the terms. This will be x minus 1 minus 2. Minus 1 minus 2 is minus 3 divided by x minus 1 the whole cube e power x dx. Correct? Separate the terms. I wrote x minus 3 as x minus 1 minus 2 so that minus 1 minus 2 if you add you get minus 3. Now you can separate the terms. X minus 1 by x minus 1 the whole cube minus 2 by x minus 1 the whole cube. Separate the terms. This becomes integral of x minus 1 divided by x minus 1 the whole cube minus 2 divided by x minus 1 the whole cube into e power x into dx. Separate the terms. Divide this by this by this. Okay, x minus 1 by x minus 1 the whole cube. X minus 1 cancels. What remains is integral of 1 by x minus 1 the whole square minus 2 by x minus 1 the whole cube into e power x into dx. Like this we get. Derivative of 1 by x square is minus 2 by x cube. To take f of x as 1 by x minus 1 the whole square. Derivative of 1 by x square is minus 2 by x cube. This is f of x. This is f dash of x. Derivative of 1 by x square is minus 2 by x cube. So derivative of 1 by x minus 1 the whole square is minus 2 by x minus 1 the whole cube. Minus 2 divided by x minus 1 the whole cube. Derivative of 1 by x square. Derivative of 1 by x square is minus 2 by x cube. So derivative of 1 by x minus 1 the whole square is minus 2 by x minus 1 the whole cube. This is f of x, f dash of x. This is your f of x. Along with minus sign, this is your f dash of x. So integral of e power x into f of x plus f dash of x is e power x into f of x. 1 by x minus 1 the whole square plus a constant c. F of x, f dash of x. So answer is e power x divided by x minus 1 the whole square. Answer is e power x divided by x minus 1 the whole square plus a constant c. I wrote minus 3 as minus 1 minus 2. Separate the terms. X minus 1 by x minus 1 the whole cube minus 2 by x minus 1 the whole cube. X minus 1 cancels. Derivative of 1 by x square is minus 2 by x cube. No, derivative of 1 by x square is minus 2 by x cube. Likewise, derivative of 1 by x minus 1 the whole square is minus 2 by x minus 1 the whole cube. This is your f of x, and along with negative sign it is f dash of x. E power x into f of x plus f dash of x. E power x into f of x plus, if you want you can write the reason why we got like this, because integral of e power x into f of x plus f dash of x is equal to e power x into f of x plus c. E power x into f of x plus c. Move on to the next one. Take the integral as I. I is equal to integral of x square plus 1 divided by x plus 1 the whole square into e power x dx. Here also I have to reduce it to that form. Integral of e power x into f of x plus f dash of x. To bring it to that form, I should make some adjustment here. I'll express the numerator in terms of denominator. That's the main thing. So that I want to identify what is f of x and f dash of x. Sometimes it's straightforward. Sometimes it won't be straightforward. You have to make some adjustments. Sometimes you use trigonometric formulas. Correct? All those things are there. So this is equal to integral of x square plus 1. You can write it as x square minus 1 plus 2. And group these two as one term. Like this. Into e power x divided by x plus 1 the whole square. Correct? Plus 1 is minus 1 plus 2. I wrote plus 1 as minus 1 plus 2. Then separate the terms. Numerator is sum of two terms. No? X square minus 1 is one term. 2 is another term. Separate. Divide individually. So what we get? This is equal to integral of x square minus 1 divided by x plus 1 the whole square plus 2 divided by x plus 1 the whole square into e power x dx. Divide this by this by this. X square minus 1 you can factorize x minus 1 into x plus 1, right? This is equal to integral of x square minus 1 is x minus 1 into x plus 1 divided by x plus 1 the whole square plus 2 divided by x plus 1 the whole square into e power x dx. Here x plus 1 will cancel, correct? X plus 1 will cancel. So what remains is I is equal to integral of x minus 1 by x plus 1, x minus 1 by x plus 1 plus 2 by x plus 1 the whole square into e power x dx. Now what we can do is you take this as f of x and differentiate using quotient rule. You will get this as f dash of x. So I am getting the form integral of e power x into f of x plus f dash of x. This is f of x. You can show the steps in the side. Take f of x as x minus 1 by x plus 1. X minus 1 by x plus 1. F dash of x. F dash of x is equal to using quotient rule. Denominator square. X plus 1 the whole square. X plus 1 into differential denominator into derivative of numerator. Derivative of x minus 1 is 1 minus numerator into derivative of denominator. Derivative of x plus 1 is 1. So what do you get? X plus 1 into 1 is x plus 1 minus x minus of minus plus 1 divided by x plus 1 the whole square plus x minus x will cancel. What you get is 2 divided by x plus 1 the whole square. Correct? F dash of x is 2 by x plus 1 the whole square. This is f of x. This is f of x. This is f dash of x. 2 by x plus 1 the whole square. Integral of e power x into f of x plus f dash of x is e power x into f of x. My f of x is x minus 1 divided by x plus 1. Using quotient rule we got this. Take f of x as x minus 1 by x plus 1. If you differentiate this by using quotient rule, I'll get this as f dash of x. Use quotient rule. Denominator square. Denominator write as it is. Differentiate the numerator. Derivative of x minus 1 is 1. Minus. Numerator keep as it is. Differentiate denominator. Derivative of x plus 1 is 1. X plus 1 into 1 is x plus 1. Minus x plus 1. Plus x minus x will cancel. 1 plus 1 to 2 by x plus 1 the whole square. So this is f of x, f dash of x. Important step is this. Writing plus 1 as minus 1 plus 2. Minus 1 plus 2 is 1. Separate the terms. Divide this by this by this. Then x square minus 1 you factorize. X minus 1 into x plus 1. Using a square minus b square. A plus b into a minus b. So x plus 1 cancels. You get x minus 1 by x plus 1 there. Move on to the next one. This is direct. F of x, f dash of x. Take the integral as I. Integral of e power x into sin inverse of x plus 1 by root of 1 minus x square. We know derivative of sin inverse x is 1 by root of 1 minus x square. So this is your f of x and this is your f dash of x. Correct? Comparing with integral of e power x into f of x plus f dash of x. Answer is e power x into f of x plus c. Correct? E power x into f of x plus c. What is your f of x? Sin inverse of x. F of x is sin inverse of x. Derivative of sin inverse of x. 1 by root of 1 minus x square. So answer is e power x into f of x, which is sin inverse of x plus a constant c. Move on to the next one. Integral of e power x into log x plus 1 by x. F of x is log x. F dash of x 1 by x. Correct? F of x is log x. And derivative of log x is 1 by x. So e power x into f of x plus f dash of x. Given integral takes the form integral of e power x into f of x plus f dash of x. What is my f of x? Log x. Correct? Derivative of log x is 1 by x. F of x is log x. F dash of x is 1 by x. So answer is e power x into f of x plus c. So f of x is log x. So answer is e power x into log x plus a constant c. Move on to the next one. Here you can separate the terms. This is equal to integral of e power x into x by x square minus 1 by x square. Separate the terms. X by x square minus 1 by x square. Separating the terms. Okay. Numerator is difference of two terms. So separate x by x square minus 1 by x square. This will be equal to integral of e power x into x by x square is 1 by x minus 1 by x square. Correct. Now take f of x as 1 by x. Derivative of 1 by x is minus 1 by x square. Correct. F of x is 1 by x. Derivative of 1 by x is minus 1 by x square. Derivative of 1 by x minus 1 by x square. This is your f of x. And this is your f dash of x. And we know e power x into f of x plus f dash of x. Integral of that is e power x into f of x plus c, which is e power x into f of x is 1 by x plus a constant c. Derivative of 1 by x minus 1 by x square. F of x is 1 by x. F dash of x is minus 1 by x square. Integral of e power x into f of x plus f dash of x. E power x into f of x plus c. Next one. This question asked in 2025 Karnataka PU board exams as a MCQ. I is equal to integral of e power x into cos x minus sin x. Cos x minus sin x into dx. Here derivative of cos x is minus sin x. Correct? This is f of x and this is f dash of x. Derivative of cos is minus sin. F of x equal to cos x. Derivative of cos x minus sin x. Derivative of cos x is minus sin x. Integral of e power x into f of x plus f dash of x. Answer is e power x into f of x plus c. So this is e power x into f of x is cos x. E power x into f of x. F of x is cos x. Derivative of cos is minus sin. Correct? E power x into f of x plus f dash of x. F of x is cos x. Derivative cos x. F dash of x is minus sin x. So answer for this integral is e power x into f of x plus c. F of x is cos x. Next one, integral of e power x into 1 plus tan x plus tan square x. Here we can make use of the identity 1 plus tan square x is secant square x. What is given? Integral of e power x into 1 plus tan square x I'll write first. So that 1 plus tan square x will be secant square x, correct? I am writing like this. 1 plus tan square x plus tan x. So that 1 plus tan square x written in one bracket. 1 plus tan square x is secant square x and derivative of tan x is secant square x. So that it takes our general form, that is in e power x and f of x plus f dash of x. 1 plus tan square x is secant square x. F of x is tan x. So what you get is integral of e power x into, what is my f of x? This is f dash of x. F dash of x plus this is f of x. Correct? F of x is tan x. F dash of x is secant square x. F of x is tan x and derivative of tan x is secant square x. Integral of e power x into f of x plus f dash of x is e power x into f of x plus c. E power x into f of x is tan x plus a constant c. Same type of question is there here also. Take the integral as I is equal to integral of e power x into, combine 1 plus cot square x in one bracket. Okay. Then plus minus cot x in another bracket. 1 plus cot square x is cosecant square x, right? 1 plus cot square x is cosecant square x. You can write 1 plus cot square x, the trigonometric identity, square relationship we have. I combine the first and last in one bracket. 1 plus cot square x is cosecant square x plus minus cot x. You know, derivative of minus cot x is plus cosecant square x. Correct? This takes the form integral of e power x into f dash of x plus f of x. F dash of x plus f of x. What is my f of x? Minus cot x. F of x is minus cot x. Derivative of minus cot x is plus cosecant square x. Derivative of cot is minus cosecant square. Derivative of minus cot x is plus cosecant square x. So f dash of x is this and f of x is this. Correct? So answer is e power x into f of x plus c. Substitute back for f of x. F of x is minus cot x. So answer is minus e power x into cot x plus c. So this is about integrals of the type e power x into f of x plus f dash of x. Making use of the identity here. 1 plus cot square x is cosecant square x and minus cot x kept as it is. Derivative of minus cot x is plus cosecant square x. And four more formulas are given here. Just learn this. I'll be doing it all these things synopsis. This is for competitive exams. Integral of e power ax into a f of x plus f dash of x is e power ax into f of x plus c. Integral of e power f of x into 1 plus x into f dash of x is x into e power f of x plus c. Integral of a power x into log a f of x plus f dash of x is a power x into f of x plus c. And integral of x into f dash of x plus f of x is x into f of x plus c. All these things quite important for competitive exams. I'll be doing the synopsis part of indefinite integrals and also I'll be solving NCERT exemplar book completely of all the chapters, second PU as well as first PU. That is also there, and PYQs also I'm doing from 1984 to 2025 of CET exams, and even for JEE exams also I'm doing. Okay, please subscribe to my channel, watch the videos and understand it. It will be beneficial for writing exams. Even for teachers also these videos will be very beneficial, because here and there they can just see the video and go to the class. Preparation is not required. Everyone carries the smartphone nowadays, correct? So data also will be there. It's not a big issue. So even while making a journey also you can refer to the mobile and see the videos and make the preparation. So it's even helpful for lecturers also. And for beginners also it's a very useful course. All these things I'm doing in detail everything, and also I'm covering the concepts as well as even the NCERT exercise I'm solving. I'm taking each video by level by the NCERT exercise. NCERT exercise 7.5 one video, 7.6 one video, like that. So exercise wise I'm doing the video. Okay, so that will be quite helpful. So learn all these formulas, useful for competitive exams, and the questions are already asked based on these formulas. In KCET 2009 one question was asked connected to this. Also in the NCERT exemplar book also these type of questions are there. Okay, so with this I completed integration by parts, the NCERT exercise 7.6 completely. Along with the concepts we learned integration by parts formula first, integral of first into second, first function keep as it is, integrate the second, minus integral of integrate the second, differentiate the first. And also we learned integral of e power x into f of x plus f dash of x, e power x into f of x plus c. And many more formulas I gave. Integral of e power x into sin bx, e power x by a square plus b square into a sin bx minus b cos bx plus c. Integral of e power x into cos bx, e power x by a square plus b square into a cos bx plus b sin bx plus c. Integral of log x is x log x minus x plus c. Integral of sin inverse of x into sin inverse of x plus root of 1 minus x square plus c. Integral of cos inverse x into cos inverse x minus root of 1 minus x square plus c. Integral of tan inverse x into tan inverse x minus half log 1 plus x square plus c. Integral of cot inverse x into cot inverse x plus half log 1 plus x square plus c. Correct? Integral of secant inverse x into secant inverse x minus log of mod x plus root of x square minus 1 plus c. Integral of cosec inverse x into cosec inverse x plus log of mod x plus root of x square minus 1 plus c. All the formulas please learn. Okay. With this I conclude. Thank you.